Hello, everyone. Welcome to the 2024. I cannot believe it's the 2024 edition of the workshop, Economics of Low Carbon Markets. It's an honor to have you all here. Thanks a lot for our sponsors, FAPESP, Fundação de Amparo à Pesquisa do Estado de São Paulo, FIP, Fundação Instituto de Pesquisas Econômicas, our Department of Economics, and FEA USP, and the University of Oldenburg. It's our partner on doing some of these editions in the years back. And I'd like to thank Professora Maria Dolores, our Dean, for joining us in the beginning and being available to give some welcoming remarks. Thanks a lot.
Good morning. Thank you so much, Claudio. Oh, sorry. It's a great pleasure to welcome all of you in this 2024 edition. I don't know if they started at 20 or
11 years ago.
11 years. So it's a remarkable event that discuss and that has a great history. It's an honor to open this exciting edition. First and foremost, I would like to extend a warm welcome to all of our participants. We are privileged to host Professor Wolfram Schlenker, yes, from Harvard University, who will deliver a keynote lecture on global implications of carbon taxes, a topic of immense relevance as the world grapples with decarbonization challenges. Additionally, we are thrilled, oh, sorry, I will mute this. Okay. Additionally, we are thrilled to welcome Professor Eric Mulliger from UC Davis, whose insights on decarbonizing transportation will shed light on critical opportunities and challenges in this area. So thank you so much for your presence here. At FEA USP, sustainability and transition to a low-carbon economy are central to our commitment to fostering dialogues that connect academia, policy and industry. These themes are also integral to inspiring and equipping our students, the next generation of leaders, I'm sure, with the knowledge and tools to address the most pressing challenges of our time. I wish to express my heartfelt gratitude to the organizing team, particularly Professors Claudio Lucinda and Ariaster Chimelli. Their dedication and hard work have been instrumental in making this event possible. Thank you all for being here and contributing. Oh, Rafael Pucci also, sorry. Yes, yesterday we are discussing, and so, but thank you for you three. Your dedication and hard work have been instrumental in making this event possible. Thank you for being here, everybody, and contributing to the discussions that drive impactful change. Welcome to FEA USP, and I wish you all an inspiring and productive workshop. Thank you, and have you a good time.
Thank you, Dolores. Without further ado, we are going for the first session. Clarissa will be the chair. By the way, this conference will be transmitted to our YouTube channel. Anyone that doesn't feel okay with transmitting, just let me know and we can arrange something. So welcome to the presenters, and let me get their names here. Clarissa is the chair, and we have the first paper, Rafael Araújo, and then Leila and Rafael Pucci, the second one. So.
You guys want to sit here? Okay. All right. I'll stick here. Good morning, everyone. I'm Clarissa Gandor. I'm a professor at the São Paulo School of Economics at Fundação Getúlio Vargas and scientific director of the newly launched FGV Clima, a new center for applied research in climate economics. But my job here today is just to chair this very exciting table. I am very honored and really happy to be back to low carbon markets. I saw some of the very first editions a long time ago, so thank you so much for the invitation. And I'm also very happy to be here alongside two great research into amazing colleagues. So without further ado, I'll hand right over to you guys. I'll keep an eye at the time. I'm actually gonna sit over here so that I can see you over there. Also, if we have you guys have 45 minutes for the presentation, then we have a discussant for 10 minutes, so if any questions should come up, you can interrupt, right? And I'll just make sure I'll sit here to keep an eye on the questions. That's gonna be better. Here you go.
Okay, I don't have the same ability with the mic, but I'll try. Hello, everyone. It's a great pleasure to be back home. I consider this as being my home, even though now I'm an assistant professor at the São Paulo School of Economics. I'm going to present my paper with Leila, and she's going to present the next paper, so this is kind of a nice arrangement. And Rogério, who is an assistant professor at INSPER. And thanks for the organizers. I know it's a lot of work to put all the sessions together. And thanks for putting my paper as the first one, because then I can just present and actually enjoy the other presentations. This was the first time for me. I don't need to overthink about my own presentation. So the paper is this Voting the Heat of the Moment, Climate Change, Salience, and Electoral Behavior. And this is something that this is actually a short paper, so I'm not gonna use the 45 minutes. But this is something that is very dear to me, because we are spending a lot of effort in academia drawing optimal policies for addressing climate change, but at the same time we are voting for Bolsonaro and Trump, and so I wanted to have a better understanding of what goes on inside people's head. And this is not working. No, it's just that it's not okay.
Let me see if they plugged. Maybe they didn't.
Yeah, I can just use it here. It's
Yeah,
okay, it's okay.
Okay.
I can go back and forth here. No problem, no problem.
If you want, I can.
No, don't worry, really. Okay, it's very technological.
Very technological.
There it is.
Very technological.
Okay, how many PhDs we need to change the slide? So I don't need to spend much time here talking about the importance of climate change and its significant costs, especially for poor countries, right? I hope I don't need to spend time here. And avoiding this climate crisis, or at least doing some damage control here, requires us to drastically reduce our emissions. And so this is some scenarios from the IPCC. And what we see is that to keep our planet livable, we need to drastically reduce our emissions, in the sense that we need to reach net zero emissions in a time window of 10 years. This is a Herculean task, a very, very difficult thing to do, because this requires a lot of international cooperation. So we need China, we need India, we need Europe, we need the US, and we need Brazil as well. We need all aboard to address this climate crisis. And with the majority of the world living under a democratic system, at least for now, who knows, we, especially the rich world, we need to understand ultimately what is going to lead to the climate policies being implemented or not, are people voting, right? People voting for politicians that are going to actually address the climate crisis. So the main idea here is to understand what drives people to vote for climate policies. And this is a very difficult question to answer, because there's a lot of information going on here when people choose on who to vote, especially when it comes to climate policy. So if you are going to vote for a politician that's going to address the climate issues, we need people to believe. People need to believe in climate change. And yes, this is still an issue, which is kind of weird, but it happens. The voter needs to believe that climate change is caused by human action, that climate policies can actually do something to address this issue, and that it's the politician that they are going to vote for that's going to actually do something and act on climate policies. In this context of climate change, information is very costly to acquire, and there is widespread misinformation. So if you type climate change on your Google search or YouTube and scroll down to the second page, you'll soon see how widespread is the misinformation on that matter. And so what this creates this lot of misinformation, and the fact that the information is costly is that it creates a lot of room for behavioral economics. So how can we use different mental models to understand how people are going to decide on who they're going to vote for? And so the main essence of our idea in this paper here is that climate change is going to be perceived through our ordinary business of life. So it's our perception of the climate on our day-to-day that's going to drive our actions related to climate policies and politicians that are pro-environment or against the environment. So the main question here is, it's simple, but we think it's important, of can higher temperatures make people vote for climate policies or for green politicians, or however you want to call this. And in this paper, the specific question we want to understand is if short-term temperatures changes is going to increase voting for a pro-environment politician. And the idea of using short-term temperatures here is that we want to address this idea of the salience of climate change. So as I was saying, there are a lot of different mental models that can explain people's behavior, but we want to focus on this one of salience, in the sense that, okay, maybe you know that climate change is real, but your perception of the matter is going to be driven by your day-to-day, the day-to-day way you see the world. And what we are trying to sell in this paper here is that we believe in Brazil we have the perfect setting to address this question, to answer this question. And that's because of Marina Silva. So Marina Silva, she was a presidential candidate in 3 Brazilian elections, so 2010, 14, and 18. And she is a clear environmentalist. So we do not need to be classifying politicians on whether they are green or not, or use vote for green parties, and maybe the green party is not actually green, they are just called green parties. Here we have a candidate that is a very clear environmentalist running in 3 consecutive elections. And what this gives us is a nice data on 3 presidential elections in Brazil, so 2010, 14, and 18, which gives us a lot of geographic variation on how people are going to vote. This gives us panel data on voting, and we can merge this with temperature data also on the municipality level, which also gives a lot of temporal and spatial variation that we can use to build panel data for the same candidate in a whole country, in a continental country. So this is how we try to sell this paper, the idea of a perfect setting. And also we are going to be using municipal data on voting, but also the wet bulb temperature, which is a better way of measuring how people perceive the temperatures on their day-to-day matters. Okay, so who is Marina Silva? If you are a Brazilian, I'm sure you know, and perhaps you know even if you're not a Brazilian, because she's a very famous person. This is an editorial from Nature. So Marina is very famous for being a protector of the Amazon forest. She's also constantly present in the pop culture in Brazil. So in Brazil, it's very hard. I cannot imagine that you can find someone in Brazil that doesn't know who Marina Silva is and who doesn't see her as an environmentalist. This is, I think this you can take for granted. She is an internationally recognized activist. She won a lot of prizes about conservation and the environment. And she is deeply connected with the birth of the environmental movement in Brazil. So this is Chico Mendes, another activist. He was murdered by farmers because of his activism. And this is Marina Silva in the beginning of her career as an environmentalist, as a politician, as a union leader. So this is Marina Silva. Perhaps she's mostly recognized by this graph here, which is the deforestation in the Amazon. So we had that in the 90s and the beginning of 2000s. We had some years where we would observe 20,000 square kilometers of deforestation in the Amazon. And then came Marina Silva, and I know this slide is pretty good, right? And then came Marina Silva, and she had this PPC-done policy that is the coordination among a lot of different ministries. Clarissa has an amazing paper about this. So you use satellite monitoring and you increase enforcement of environmental laws. And she brought deforestation rates down in the Amazon from 20,000 square kilometers to 4,000 square kilometers. And that's what she's most famous for. Okay, so let's go through the literature a little, just to try to show you what we are trying to do in this paper in relation with the previous literature. So first, there is a lot of papers on voting behavior and contextual circumstances. So it's something that happens on the day of the election that is going to affect the way you vote. So for example, if it's raining, and this is a huge literature in the US, if it's raining, you're not going to vote, it affects turnout, and it seems that it creates a habit. So it's a very important literature. This is not the kind of mechanism that we are addressing here, but just to point out that this is a very important literature. But most of this literature focus on things that are happening that are giving the voter more information about the candidate. And here, what we are trying to show is that it's these contextual circumstances that is making people reevaluate their priorities. So if it is hot today, then maybe I will perceive this matter of climate change in a different way. The second literature is the salience of environmental issues. There are a lot of papers about this, a lot of papers on natural disasters, for example. But the idea of our paper here is to isolate the salience on voting behavior beyond stated beliefs. So for example, in surveys, if you ask people whether you believe in climate change or not, this is beyond stated beliefs because we actually see the action of people voting, and we are focusing on the constituents' votes here. The closest paper here is your paper, but it's a little different because it uses Google searches to actually see if people care about climate change, and to also to see whether politicians are going to vote for climate policies given weather variations. And also we want to point out that this paper is about a developing country, and we think this is important because most of the literature focus on the rich world, and the public perceptions about climate change is very different depending on whether you live in Europe or in Brazil, for example. So if you say you want to protect the Amazon, depending on where you are in Brazil, people are going to get angry at you. So this is a very different scenario than in rich countries. And we believe that Brazil is a relevant setting to understand how people are going to vote for climate policies, because Brazil has the potential of increasing its carbon emission by a lot, because you have the Amazon, it's 200 billion tons of CO2. So there is this constant threat of a tipping point in the Amazon that could emit almost 5 years of equivalent global emissions, so it's a lot. So it would be catastrophic. So it's important for us to understand how Brazilians are voting. Okay, so all of this package but the paper boils down to a simple specification and the use of a simple variation here. So we are going to use municipal data voting for 2010, 2014, and 2018. This is more than 5,000 municipalities. We are going to merge this voting data with the daily wet bulb temperature at the municipal level, so we get this temporal variation because we have panel data, and we also have some controls of gender, education, and income. So we are going to estimate this expression here, which is the share of votes for Marina Silva, right? So this is a ratio on the temperature, the wet bulb temperature, on the day of the election. So this is really high frequency data, high frequency variation that we are exploring, and we want to estimate beta here. As we have controls and these fixed effects, the variation that is actually identifying my parameter is this variation of temperature around the long-term average of temperature. So that's why this specification is widely used, because this variation is easy to argue that it's exogenous, especially because of the high frequency that we are employing here, okay? Okay, so what do we find here? So my initial guess is that we would find just 0, 0, 0, because I was surprised to actually find some effect here. So just think about it. It's kind of hot today, and then I'm going to vote for an environmentalist. This is something that was unexpected for me. So we find positive effects when we change our controls, but this doesn't tell us very much. What tells us a lot about the magnitude of this effect is if we do the usual exercise of multiplying the estimated coefficient by the standard deviation of the independent variable. So the beta times the standard deviation of the temperature gives an effect of 1.3 percentage points. So this is a lot. It's 1 percentage point of more votes for Marina Silva because you have a 1 standard deviation in the wet bulb temperature. Okay, but Brazil is a big country, so we have a lot of spatial heterogeneity. So this is not a very fair comparison, but we can also estimate the standard deviation at the municipal level, so only leveraging the temporal variation here, and then we can multiply the beta by the expected value, the average value of this temporal variation, and this gives us an impact of 0.6 percentage points. So I think this is amazing because it's an increasing temperature that can explain 0.6 percentage points for voting for a black environmentalist woman in Brazil, and this is a huge impact. And what is also very interesting is that one very close paper to ours is this economic journal paper on the salience of school infrastructure. This is using data from Argentina, and what the authors actually show is that when voters are going to vote in the public school that they are going to vote in has poor infrastructure, the voters are going to punish the incumbent. And the impact here, the impact of voting in a school with poor infrastructure is of 0.6 percentage points. I find this very interesting because this is a totally different setting. This is a totally different mechanism, but it's the salience of something that is happening on the day of the election, and we find the same result. It's almost as if we were living in a simulation, and the parameter that determines these contextual circumstances is 0.6. And one of the referees didn't like it, and so I think, why? Like, I don't know. You have to be curious about how the world works, right? Okay, in 2018, maybe you know this guy. In 2018, the presidential elections in Brazil was kind of crazy, so the vote share of Marina Silva melted. So we have a robustness exercise here where we exclude the year in which Bolsonaro was the winner, and our results are not driven by the existence of Bolsonaro. Also, we have a placebo exercise here. So if our mechanism makes sense, the temperature after the day of the election shouldn't have any results on votes for Marina Silva. If it were not true, then it could be the case that there is some unobservable variable that's actually driving the results, but we find a zero effect on the temperature on the day after the election, which is good. Okay, and there are possible other mechanisms that we want to explore. So this is just our baseline specification. But as I said, there is this huge literature, especially in the US, about contextual circumstances and turnout. This is not very important in Brazil because voting is mandatory, but we knew that if the referees would ask about this. And so we have this effect here that is marginally significant, so there is no impact of higher temperatures on turnout. And even if you want to see this as an effect, then we would need some explanation of why turnout is benefiting Marina Silva specifically. And we don't have a way to rationalize this, but we think that there is no impact on turnout. Okay, and where are the votes for Marina Silva coming from? We first try to understand if it's hot today, I'm punishing the incumbent, and this is not what is happening. The incumbent here would be the Labour Party, and this is not what is happening. So actually the effect is coming from the parties on the left and on the right equally. The point estimate is different, but they are not significantly different. And so the voters are coming from the other candidates. So it's not coming from turnout, it's not coming from the incumbent, it's coming from parties on the left and on the right. So it actually seems that people sees Marina Silva as the environmentalist, and if it's hot today, I'm going to vote for Marina Silva. And finally, another mechanism that could explain this is inattention. So it's hot today, I'm angry, I don't type the numbers correctly when I'm going to vote, and that this somehow is going to benefit Marina Silva, even though I cannot rationalize why. But we don't see any evidence of inattention here because the share of nulls and blank votes, the impact is zero as well. Okay, so why looking at temperature only on the day of the election? So on the election day, because first, if we take a larger window time and compute average temperatures, then this is going to be a problem because this can affect your income, for example, your productivity, and this will change your perception of the political scenario. We want just to focus on the salience here, but we can explore a couple of days earlier to understand the dynamics of this decision. So this is just our placebo exercise is here. We have the impact on the day of the election, and we have a similar impact on the day prior to the election. So if it's hot yesterday, I'm going to vote today, this is still going to have an impact. But we don't see any impact on 2 or 3 days before the election. And this is kind of surprising, but not so surprising if you know a little of the literature on behavioral economics, because actually this kind of figure is very common in behavioral economics. It seems that this salience mechanism is only has an impact on the day that you are making the decision or the day prior to the decision. It seems to be pretty common in behavioral economics to find this kind of figure, which is interesting, but also it's kind of a concern, right? Because it shouldn't be this way. Like you should have the information on climate change, and 1 or 2 days shouldn't make any difference, but it seems that it does. Okay, you might know this paper here, not very influential, just a couple of citations about the nonlinear temperature effects that destroy an entire literature. But we wanted to see if this happens also in our case here. So this is just our baseline estimate. And what we are doing here is that we are interacting the temperature with dummies for the quantiles, just to see if the effect depends on the level of temperature. So, and the idea here is that we are plotting the four quantiles and the interactions, and the coefficients are all the same. So it doesn't matter whether it's really hot today. What matters is your perception on what you are used to as a temperature and the shock that you are receiving today. And this is kind of surprising as well, that it doesn't seem to be the case of the level. And maybe this is a feature of the Brazilian political system, because the elections happens on October, so in a lot of places it's not really hot. But what matters is the deviation from the average here. And this is kind of interesting because it seems to be the perception of people of climate change, and not only if they are uncomfortable with the weather. Okay, so in conclusion, a changing climate can affect how people is going to vote. Of course, we are constrained by our methodology here. We can just use this variation, this high frequency variation. And the effect is short-lived, as I showed you in this figure, which is a common finding in behavioral economics, which is kind of a concern here, because we wanted to understand whether climate change is going to actually change how people vote for politicians. But if the effect is only present on the day of the election, then it doesn't seem to be the case, right? As climate is going to get worse, we can kind of expect more people to vote for climate, but there are a lot of caveats here, especially if the reference point of people doesn't change very fast. Because if their reference point of what a normal temperature means change very fast, then this is going to be a problem. They are constantly updating what they are used to. And finally, aside from all of these environmental questions, this is more evidence that circumstantial voting behavior is important, because we find these 0.6 percentage points only coming from a one standard deviation in the temporal variation in the temperature, and this is a huge impact, and this kind of shows the importance of understanding other mental models of voting behavior. And as I anticipated, this is a short paper, so this is my whole presentation, and thank you.
Do you have any questions before we go to the discussion? No? So, on the other half. You can actually go over the 10 minutes if you like, if you guys want to discuss it, because there's time.
I probably won't, but
Okay. Deve ser onde está o dongle do clicker. O dongle é o pitoquinho USB que conecta. Now you know.
Now I know. Learning. Eu não sabia o que era. Eu achava que era point.
você pode usar daí, né? É que eu preciso tirar pra... Aham. Posso colocar isso aqui no Rafael?
Essa é o ponto,
Ele
não
vai,
jeito, né?
ele vai me dar depois essa. E aí, quer botar aqui? Não.
It's cutting a little bit.
Okay, so hello everyone. Thank you all for being here, and thank you Rafael for the excellent presentation. So this is the fact that this is a short paper makes the job a little harder, because it's like you have to really dig something to say. But the thing is that I really like this paper. I think it's really interesting, and it is one of the things that I really like is that it's really straightforward. So it's really to the point. So there's not a lot of, you don't have to explain too much. The instrument is easy to understand. The question is very clear. So I really like the fact this is a very objective work. So just to, I'm gonna recap it. I'm not sure if this is needed, but so from my perspective, this paper is about The question here is, does salience of environmental problems affect voting behavior? And specifically, if the temperature is abnormally high in the day of the election, does the voter choose a pro-environment candidate? And what the authors do, they explore this variation in wet bulb temperature across municipalities in Brazil and also across these election cycles, 3 election cycles. And basically what they're saying is that the temperature is deviating from the average across these sources of variation, then the voter is going to choose is going to vote for Marina. And and what they find is that the votes for Marina increase, and this is a significant result. It's large, it's important. And they also find that the effects are short-lived. So basically, this is what we just see.
Microphone for the transmission. You need. Yeah.
Okay, so blah, 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 and now, so what I liked about the paper that I kind of said already, but the question is relevant. I mean, we are all here, we understand that this is relevant, and the answer is provided with a nice use of data and a nice use of the variation that we have in Brazil with thousands of municipalities and a lot of election cycles. The identification strategy, I think, is well known and widely used, so it's temperature shocks into something. So I guess this is pretty easy to argue that there is no endogeneity in the instrument. And what I said is that I like, because this paper is very, very objective, very clear, so it goes directly to the point. So I think this is one of the strong features, is that it's just very straightforward and a straightforward paper. So I like the paper. Now, one thing that I was thinking about to comment is more like maybe it's a more philosophical thing, right? Because I know that you're exploring the variation across many, many municipalities, but you're also exploring, and it is important for you, the variation across the election cycles. And for me, when you say that these, the coefficient is capturing changes or deviations from coming from abnormally high temperatures, I was kind of confused how you can say that if the average is based on 3 days across a very long period, because it seems to me that the perception of temperature is something more like short, that comes from a short run thinking, right? So what you're trying to say here is that the voter in the day of the election kind of compares the temperature in that day with the temperature 4 years ago, and then he decides to vote for Marina. And I understand that you're trying to say that this is a deviation from what he's used to, but at the same time, you're just averaging 3 days, like just 3 days. Your average is based on just 3 days. So you only have 3 points of observation over time. So I'm not sure if this is really capturing this perception of an abnormally high temperature. And I'm not saying this is a threat to the identification. I mean, this is totally solvable with some robustness test. Maybe you could just do the deviation of the average based on the last year or the previous days or something like that, so that you try to capture this sensation of the voter that he is indeed looking at a day, and this day is really, really hot compared to what he thinks this day should be. I don't think he's looking that far back. He's probably looking at the last few days, and if it's too hot, then he's going to change his mind and vote for Marina. So again, I don't think this is really an issue with identification or anything, but I think it's a simple robustness using, I mean, you have data for all the days of all the years, so it's pretty simple for you to just run some deviations from the average using the same month, or maybe the same month in the last year or something like that. Okay, just to kind of alleviate this sort of concern with the amount of information that you're using for calculating this average of temperature. Okay, I know you use cross-sectional variation, but I understand that the temporal component is important. And the second thing that I wanted to comment is about the turnout, and I know it's a very small effect, and again, I don't think it's going to change the coefficient or your estimates or your conclusions, but there is a small effect on turnout, and we know that Marina Silva could be seen as like the trendy or the alternative to the establishment candidate when she ran. So maybe just because she's sort of the third alternative, she's different from the others, she could be seen as someone that it is worth going out to vote for. Okay, so maybe this really small effect could be coming from just, I want to participate to vote for Marina because she's different. She's talking about things that the other candidates are not talking about. Especially because in one of the elections you're using is when Eduardo Campos died, and then there was a lot of commotion because she was his vice president. So maybe it would be nice to see how much of that is playing into the estimate. Okay. So I think you could just see if the dynamic of turnout is similar to the dynamic of the vote share. So maybe you could plot that dynamic effect for turnout and see if there's anything that makes sense. And you could also see the correlation between the vote share and the vote share for Marina and turnout is any relevant or not. Okay. And maybe you could also drop the year in which she ran and Eduardo Campos had died, because maybe that could be driving the effect on turnout, for instance. And then some other comments that I was trying to think about. So I think the figure 1 is very compelling, the one that has the dynamic effects. I think this is really nice. You show that it's not, and I like to see that it's on the day before it also has an effect, because it makes sense that it's not just the day of the election, but the last day as well. And this fades out, so this is really interesting. I would like to see the forward legs as well, just to show us that it's more like a placebo. So you're showing that -2, -1, and then +1, +2, +3. The same thing you do for the legs, you do for the forward legs, just to show that there is really nothing happening. And I agree that this white bulb temperature is the best way to go. But while reading the paper, I think it would be nicer to give a little more of a sense about the magnitude of these white bulb temperatures. So what's a large number, what's a small number? I know you give an example like this. You explain what wet bulb temperature is, but I would like to understand the table, the magnitudes of the table. You have an average of 23 and a standard deviation of 4. What is exactly that mean? What's a very high white bulb temperature? What is a small, low wet bulb temperature? And also the model that you're using, it's kind of giving the same weight for above average and below average temperatures. But I think the argument that you're making is just that if it's much hotter, then you're going to vote for Marina, and if it's colder or anything, it doesn't really make a difference. So maybe you could think about another way of measuring deviations, but just the positive deviations. This could be, if everything is working, maybe the effect would be stronger if you do that. Also, you test without 2018. I would do this combinatorially, okay? So just drop the years combinatorially, just 1 by 1, then 2 by 2, just to see what happens with the effect. It should hold, but it's just a way of showing that it's really not about the election cycle, but it's just it is across all the election cycles. But then again, you would have to find a way of calculating the averages for the baseline temperature, because it would have fewer years, but I think this is not really a challenge. And the test on the effect on incumbent chair, which is one of the last things you showed, do the same thing as you do here, just drop to 2014, I think, which is the election when Eduardo died, just to see what happens with the incumbent chair. I think the concern here is that this election is playing some role because it was really dramatic, so just to see if this is an issue or not. Okay. But overall, I know these are very small comments, right? Overall, the paper is very nice and very convincing. I was just trying to add some elements that could make your life easier should you face another round of revisions. That's it. Thank you.
You got one to reply to
I
anything?
don't think so.
No? All right.
It's
That's
okay.
fine. And no, okay, questions, great. So let's see, your hand was up first, then over here, then back there.
And my question is the following: how you are accounting for the fact that Marina was not behaving as an environmentalist? Because if you, especially in the last election, she was not talking about environment. She was talking about like the macroeconomic tripod. She was talking about austerity. And how is this accounted for? Because you are supposing that people know that she's an environmentalist, but she was not her discourse. She was not talking about climate change. She was not talking about biodiversity. Okay, these subjects, they were not there. It was more about education, it was more about security, all this kind of stuff. That's my first question. Second one, very quick. How about the correlation in the cross-section dimension between temperature and approval of Marina? Because she's coming from the north. The temperature is high there. So she's better, she's more well-known there. Maybe if you could do some exercise with the polls, to see if there's some correlation between her acceptance and rejection, and across the cross-section, just to make sure that this temperature change that you are measuring behind your causal effect is not coming mostly from the cross-section, and is not taking this kind of spurious variation related to the fact that she is more well-known in Acre State, she's more well-known in the north.
Okay, just to quickly answer. Yeah, I kind of don't agree with the first comment. I think Marina was talking about a lot climate policies during her 3 campaigns as a presidential election. You can see the program of her government. And what's important here is that it's relative, right? Compared with the other candidates, she was the one that was talking about the most about climate policies. So about energy transition in Brazil. She was proposing a carbon tax on 2018, on her 2018 campaign, and the other candidates, they were not. So I think that's, first it's relative, and second, I think she was actually talking about climate policies. And about the second comment, we are not using cross-sectional variation here because we have the fixed effects on the municipal level. So we are only exploring this variation along the long-run average. So to invalidate this, we would have just have some weird distribution of temperatures on the north or compared with the south of Brazil. But this is kind of why this variation is so widely used, because it's the variation along the long-run average. So it doesn't take the variation from the cross-section, but the temporal variation. But yeah, I think on your first comment, it's hard to do this in the presentation, but like in the paper we have a large background section talking more about the campaigns, the 3 campaigns of Marina Silva, and kind of her biography to try to explain why we see her as the environmentalist in the campaigns.
Just one thing about the second one, because the patterns of variation across time are different in the north and in the rest of the country.
Yeah.
Only about cross-section.
Yeah, sure.
Over here.
So, I thought 2 things I thought were really interesting were that you were able to look at sort of where the votes were coming from, because I think it's a really,
I'm sorry.
So I think one of the really interesting elements that I thought you got at was sort of where the votes are coming from, in terms of whether you saw a reduction in the vote share for sort of left of center versus right of center parties. And I think that sort of speaks a lot to the political economy of sort of what's going on. One additional thought I had was whether it would be possible to interact temperature with some of your demographics to look at heterogeneity. So you could imagine that different groups might be more or less responsive to temperature. And I think the one that sort of jumps obviously to mind is sort of if you have information about the average age of voters in a particular area, you might expect young voters versus old voters to respond differently, and that might speak to some of these longer term impacts on voting that you might be interested in.
You can respond.
No, just say that, yes, we should do that to understand better how demographics are driving these results. And I think this is actually going to help us understand better the controls, right?
Sure.
He preempted me, but I'll follow up anyway. So to the first question, I think you just put in municipalities' specific time trends. If you really, I mean, sometimes warming isn't uniform. So I don't think this is happening, but to the first concern, if the north is warming more and there's in the Amazon and more of a push towards the Green Party, you could get a spurious. But just put in the sensitivity. I also like, I mean, I was struck by when you, in your first column, you had 0.001, and if you put in the demographic controls, it triples. So having the interaction, I think, would be really great. It's not just an additive, but interacting them, I think that would be great as well. And I think the first one with the municipality-specific time trends, that could also explain the turnout a little bit. If the turnout is differently trending across, I mean, you have only year fixed effects, which is all of Brazil together, and that could have helped explain a bit more. There is another paper, I don't know whether you're aware of it, by Fred Finan, Tedesco, and Suresh Naidu, that look at this something very similar in the US, but they look the whole year, not just the day of the election. They use precinct level data, so it's the same candidate, but the candidate has different precincts, and they see in the precincts where they have higher temperature, they get more of a shift than for the same candidate that is for the same precinct that don't have the shift. So it's not the day itself, but the year, but you can also link up with them maybe. And then on your reference point, I mean, that's kind of interesting. There was a PNES by Francis Moore, one of your colleagues, that looked at Twitter data, and that it seemed like with the reference point shifting, they didn't tweet anymore on. So do you see that here too, that they, I mean, is there enough of a trend in those short 8 years that you can reset and sort of look at both the temperature, I mean, it was in your discussion, temperature relative to the long run average and temperature to the recent past, and whether there's a difference between the two?
Yes, thanks for the idea of using these different trends. Now I understand better your comment. Yeah, I can see that happening. On the turnout, this is something that I've been thinking a lot, because the turnout can be part of the mechanism, right? It's not a competing story here, but I think we can have a better look at that. And I didn't know about this paper. We will sure take a look at that. And
Just I took notes here.
yeah, thanks. And thanks for the comments. It's going to be very helpful.
There's one more question.
More.
You take it, thanks, happen.
Hello. So a very nice paper. I was wondering that, like, understanding the mechanism is the key here. I mean, we're trying to understand exactly what's happening when that guy is going to vote. So, in line with their comments, I was wondering on like some more heterogeneity exercises to better understand the mechanism. So I was thinking, for example, whether the effects are coming from the places where the change in temperature is higher from an average, or for example, places that are already hot through the year are getting hotter, or like places that are cold and somehow it got hot in that day, for example. So I was wondering whether the effects are coming from these different types of municipalities. And another thing I was thinking is that we have that term in Portuguese, I don't know how to translate in English, it's called thermic sensation. I don't know how you say that in English, but which is sometimes a mixture of temperature with humidity and some other measures. So I was trying to, if the mechanism is coming from the feeling that the person is actually having that day, whether using a mixture of temperature and humidity or some other measure could help understand that. Like, I find a similar effect, for example, when I use a mixed measure, might be strengthening the idea of a mechanism you're trying to explore. So just some ideas. So very nice paper.
Yes, just to the first point, we are going to address this and have more heterogeneities. Yeah. And on the second point, the wet bulb temperature is a combination of temperature and humidity. So that's why we use that, and that's the idea. The 30 degrees Celsius in Rio de Janeiro is another day on the beach, but 30 degrees Celsius in the middle of the Amazon, or where humidity is really high, it can be really dangerous. So it's already a combination of both. But Thank you.
Any other questions? Nope. All right. Thank you, Rafael.
Thank you all.
Thank you for the questions. Off I go.
Good luck.
Thanks.
Microfone, água. Água sempre é bom. Start. Hello, everyone. This is not as short as our first paper. So first of all, let me thank you all for organizing this event. It is a pleasure to be here today. My name is Leila. I was also on the other paper. And this is a joint work with Rafael, who is also here today. It is entitled A Tale of Gold and Blood, The Consequence of Market Deregulation on Local Violence. And it is about a deregulation in the market for gold in the Brazilian Amazon that lead to more illegal gold mining activity, more deforestation, and more violence. So, let me go. So there's a growing body of evidence that reveals that the illegal exploitation of natural resources often causes and it's linked to violence. And this happens because in those cases, usually people working in the illegal exploitation of natural resources won't have access to courts or formal mechanisms for conflict resolution. So in those cases, the instruments they will have to solve any disputes, territorial disputes or labor disputes, would be to use violence. And we know that from a perspective of the government, it's quite challenging to implement a type of direct monitoring strategy. So to be present over these vast territories, it's kind of hard. Usually these natural resources are, sorry, there's an echo, are exploited in vast areas, so it makes very costly to monitor directly. Also, they are usually done by many different players scattered over these vast territories, so it makes even harder. And this photo here, it illustrates our context because it is a photo of an operation to dismantle garimpo, or a mining site in the Brazilian Amazon. And as you can see there, you're using a helicopter. Usually these operations involve people from the military, people from the environmental agencies, people from the federal police. So you can see that it's quite costly to implement a direct monitoring strategy over the region. So solving this issue is a problem. A common strategy as a workaround for this issue is to try to decentralize the monitoring activity. And by decentralize this monitoring activity, we mean to delegate some part of the monitoring efforts to other agents that are in the production chain of gold in our case, but other products it can help as well. So here we are thinking about permits or certificates that would control resource exploration, and that could make buyers liable for the product, for buying an illegal product. So this can happen in gold, in diamond markets, and forest products. And the idea here is that you're creating a credible threat of punishment for buyers that decide to acquire illegal products. And because of that, you are basically destimulating these buyers to when they are deciding to acquire an illegal product. When you do that, you are also destimulating demand and destimulating the production or the illegal exploitation of these natural resources. And this is quite similar to what, for instance, Audi de Paul and Scheitman find in the informality of tax literature, so the VAT schemes, where you can use members in the production chain to discourage the informality in tax system. So here you can use buyers in the markets for natural resources to discourage the illegal exploitation of these resources, okay? So far, although we know that this threat of punishment can actually be relevant for these decentralized strategies, we know very little if they can help us to create strategies and that contribute to deter violence that is associated to the illegal exploitation of natural resources. So in this paper, we'll ask ourselves, do illegal markets react to changes in decentralized monetary incentives? And more specifically, does removing this threat of punishment against buyers will affect violence in these markets? And as I mentioned before, this is a paper, about gold mining in the Brazilian Amazon. And miners, in this case, will apply for permits. So there is a permit system in place there. And they can only sell to some authorized stores. So there is these buyers that could make this, this monitoring activity. And these stores can control actually the market, the market for gold that is coming from illegal sites. To be more specific, we are looking at a natural experiment that happened in 2013 in Brazil, and that basically disabled this decentralized monitoring for the gold market, and because it removed the liability for gold buyers regarding the products that they acquire. So with the permit system intact, this deregulation just said to the gold buyers that they were not liable anymore for buying an illegal gold. And we conceptualized this, this impact of the deregulation with a theoretical model, and we show that it should, this deregulation should first reduce the costs for these buyers for acquiring illegal gold. With that, it should increase the demand for illegal gold, increase the illegal gold mining activity, and because of that, it should also lead to more violence. So we are trying to show in this paper the evidence on two parts, first on how the deregulation led to more violence, and we'll also try to show some evidence on the mechanism, which is that the deregulation also caused illegal gold mining activity to increase after 2013. And to do that, we will use this measure of, how do I point? No. We usually use this measure of exposure to illegal gold mining activity, which is a combination of data on the location of gold deposits in the Brazilian Amazon, with the location of protected areas where mining is strictly forbidden. So we will consider that places are more exposed to illegal gold mining activity if they have a gold deposit located inside a protected area where you cannot mine legally. We'll discuss a bit more later on. And we'll use a difference in difference design and investigate whether the violence increased more in places that are exposed to illegal gold mining compared to places exposed to gold but that are not exposed to illegal activity. So our main findings confirm our initial hypothesis, and that is basically that violence increased much more in places exposed to illegal gold mining. We also see some evidence that the effect is consistent with the type of violence that we would expect. So we see that the effect is driven by male victims, homicides that are happening outside of home, also caused by firearms or knives. We also see that the effect is not coming from the illegal exploitation of other valuable minerals that are in the Amazon, and this is important for our story because this deregulation was specific to gold market, and not for other minerals. We also see that violence seems to be happening on production sites rather than other places. So where gold is being sold, and we see evidence on that the deregulation caused also some other crimes to happen, such as sexual assault and also robbery. And finally, we show evidence, this is the hardest part of this paper, and we show evidence on the mechanism, which is that the deregulation caused first the illegal mining activity to increase, and then caused violence that is associated to illegal mining. And to do that, we use data on deforestation, and we show that the deforestation associated to mining rises in exposed places after the deregulation as well. So regarding the literature, we contribute first to this literature on violence in markets with weak enforcement of property rights. We are basically showing a type of decentralized monitoring that can help to reduce violence that is associated with the exploitation of the illegal exploitation of natural resources. Sorry, my English is bad today. And also, we contribute to this literature on tax informality. As I mentioned before, we are showing that what, for instance, Audio de Paulo and Scheichman showing their paper for VAT schemes also can happen in the production of resources, the exploitation of natural resources, and that you have incentives along the production chain that can help deter violence that is associated with illegal markets. So going forward, I'll just describe briefly the institutional background, gold mining in the Brazilian Amazon, and the deregulation, what happened there. Then I'll detail the data and our empirical strategy. I'll go to the results. If I have time, I don't know if I'll have, I'll detail a bit more about all the robustness and heterogeneity tests that we do in the paper. And finally, I'll discuss a bit more about deforestation. I'm choosing to do more about the mechanism and deforestation because this is not an audience about violence, and so that's why I'll keep this part short. So gold mining in the Brazilian Amazon. First, we have to know that Brazil is the 10th largest gold producer in the world. It is responsible for 2.6% of the gold production in the world, and the Brazilian Amazon produces a third of that. So it's responsible for a large part of the Brazilian production. And also important is that 70% of the Brazilian gold production in the Amazon is done in what is known as garimpos. And this is a type of mining site where the mineral that is exploited is more readily available. I'm simplifying things here, but for instance, gold mines in the Brazilian Amazon, you do not have to draw, how do you say that? Escavar? Drill. You do not have to drill. The deposits are readily available on riverbeds, for instance, so it's easier to explore. And these garimpos are legal mining sites. They can operate legally. To do that, they must issue permits with the federal government. And in fact, many garimpos in the Brazilian Amazon are legal, but we also have evidence that the illegal mining activity is widespread. So there is this paper by Manzoli and co-authors from UFMG showing precisely that is evidence on illegal mining sites. Also, MapBiomas shows some mining sites occurring inside protected areas. An important characteristic of the garimpo gold in the Amazon, and that is important for our paper here, is that garimpo gold can only be sold at some local stores, these authorized first buyers, that are called PCOs, Ponto de Compra de Ouro, the place where you can buy gold. And these PCOs, these first buyers, can only do one thing with the gold they acquire. They have to send it to smelting facilities And these bars would be transformed to gold bars and will enter the financial system. So these first buyers are small stores, but all of them must belong to larger financial institutions. So they are branches, small branches of financial institutions. In the Amazon, I think, if I'm not mistaken, there are around 60 first buyer stores, so a smaller number that the government could track. And these 60 gold buying stores are in, I think, 24 municipalities. So these first buying stores, they could act and they must act to monitor the gold they buy. So they have to verify the permits of the product they acquire, and they have to store both the permit, the document for the person that is selling the gold, and also the receipts. They have to store it for 5 years according to the regulation. And once the gold enters these PCOs, it becomes legal. So you can see there is some room for gold laundering in this case, because one miner, for instance, could exploit gold illegally in a protected area or without a valid permit, and could, at the moment of the sale, say to the PCO that this gold is coming from a legal site, and to forge the origin of this gold. So there is room for gold laundering. And the deregulation that happened in 2013 precisely removed from gold buyers this threat of punishment if they did not do the proper verification. So before 2013, both buyers and sellers of gold had to report any potential illegal transaction from their counterparts, and they were under the anti-money laundering law, so they were both liable for any legal transaction. And the probability of punishment of a PCO was strictly positive. So if they acquire an illegal gold, they could be prosecuted and should comply with the anti-money laundering law. As an example of that, we saw, for instance, the president of the National Gold Producers Association, which is called ANORO. In 2011, if I'm not mistaken, he was actually prosecuted for transacting illegal gold. So you can see that there are many other federal police operations involving illegal gold transactions. After 2013, what happened is that some amendments were included in a legislation, this law 12,844, that had nothing to do with mining, but some amendments were included there, and established what is known as the principle of good faith. This principle says that the first buyers are not longer liable for acquiring illegal gold. It says that a first buyer, a PCO, can buy the gold, can store the documents that it received, but it doesn't have to do any verification. It can simply assume that what the miner is telling him is true. So what the law did was that in practice, it removed any probability of punishment for these first buyers. It removed the threat of punishment for these first buyers. Also, as an evidence here, we found a court decision from Itaituba, which is a municipality, a very important municipality for gold mining in the Brazilian Amazon. And the judge in this decision, he actually used the principle of good faith to say he could not make the PCO liable for a transaction, I think, that amounted 150 million of reais, something like that. So the deregulation acted as a green light for buyers to operate gold laundering. The first evidence on gold laundering is in this chart here, and it shows a type of productivity of gold garimpo sites. We actually added up all the sales coming from garimpo gold in the Amazon, and we are dividing by the total area of legal permits in the Amazon. And as you can see, it jumps in 2013, and this jump is not happening because the area of these garimpos is increasing. The area is almost flat over the period. The only thing that is happening here is that the sales of gold coming from garimpo are increasing, and this suggests that there could be some gold laundering happening there. So I won't go through the model in much detail because I think the hypotheses are clear and I won't have the time. But the idea is that we made a conceptual framework based on a simple model, which is kind of similar to what Aurel de Paula and Scheikman do in their paper of VAT schemes, and where gold, we have two markets, a downstream market with gold buyers. These gold buyers will choose either to buy illegal or legal gold, and this will depend on their prices and the probability of punishment. And miners will decide to explore gold legally or illegally, depending on the demand by these first buyers, by gold buyers. And if they decide to explore a mine illegally, they would have to face and settle disputes with other types of miners, and this would cause violence. So what we think here is that this deregulation in 2013, it should have stimulate first buyers to acquire more illegal gold, so because it reduced the risk for these buyers when transacting this type of product. And by this increased demand, it should also stimulate gold mining, illegal gold mining production. And so it should also induce to more disputes and more violence. So regarding the data, we are using 4 sets of data. The first one is gold deposits in the Brazilian Amazon. It comes from the Brazilian Geological Service, and we only have the location of these deposits, so the latitude and longitude. We do not have the size or the productivity of the deposit. This is an issue. The second set of data is the location of conservation areas and indigenous territories. This is coming from the Ministry of Environment and also FUNAI, and these are the protected areas where mining is strictly forbidden. We also use data on violence, which is basically coming from data source. It is homicides per 100,000 inhabitants, our main dependent variable. And this dependent variable is at the municipal level. So every time that I'm discussing results for violence, we are dealing at the municipal level. We are finally using data on deforestation associated with gold garimpo, and this comes from Apibiomas, and because it comes in a much finer grained level, we are doing our analysis at a finer level, which is a 3 by 3 kilometer cell level. So let me describe a bit about the exposure to illegal gold mining. So in this map, you can see the Amazon, and in gray, the gray areas represent the protected areas, and the yellow dots are the location of the illegal gold deposits in the Amazon. And what we are using here is that some of these deposits, sorry. Don't know how to click it. So some of these deposits are happening inside protected areas, for instance here, for instance some of this, and whereas others are happening outside protected areas. Every time a deposit occurs inside a protected areas, it cannot be legally exploited. So if a municipality has deposits inside protected areas, we consider that we'll have a higher probability of observing illegal gold mining simply because it cannot explore that deposit all the way. So we are defining our treated municipalities, which are black here, as the municipalities that have at least one deposit happening inside a protected area. And our controls, which will be the less exposed locations to illegal gold mining, are the gray municipalities, that are the municipalities that have gold, but those deposits are not inside protected areas. And the white municipalities are municipalities that have not any known gold deposits, and we will use them as well in our main specification, but our results all hold for considering only the subset of municipalities with gold deposits or the subset of municipalities, all the municipalities in the Amazon. Just as an illustration of the results, in red, we can see the evolution of the homicide rates in municipalities, our treated municipalities, so those that have gold inside protected areas. And in yellow, you can see the homicide rates in municipalities that have gold, but those deposits are outside protected areas. And you can see that it's in 2013 that the homicide rate picks up in the more exposed places to illegal gold mining activity. So to test that, we will use a difference in difference framework. As I mentioned, our treated is municipalities with gold deposits inside protected areas. Our controls are municipalities with gold deposits outside protected areas, and we do that using all municipalities. So here it's slightly different as usual difference in difference, and basically because we are doing this double interaction here, because we want to control for municipalities that have gold deposits. So this GD dummy is municipalities that have any gold deposits. The D dummy is just the usual dummy for after period. And the IGD tells us the municipalities that have gold deposits inside protected areas. So we are interested in estimating this beta 1 coefficient, which will give us the differential effect of the deregulation for municipalities exposed to illegal gold mining compared to municipalities that have gold but are not exposed to illegal gold mining. So we also add fixed effects for each municipality, state year time trends, and the interaction of covariates in the baseline period with time dummies. Actually, we use, there are many different covariates that we tested, so controlling for log of GDP per capita, share of agriculture, death rates by homicides and homicides, suicides, and deaths in traffic. And last thing here, we also, in our main results, we are considering only the municipalities with less than 200,000 inhabitants. This is because we want to remove from our sample this violence that is more urban related. By doing that, we are removing, I think, only, if I'm not mistaken, 8 municipalities, but our results also hold if you consider a full sample of municipalities. So this is our main results. In the first row, we can see the beta 1 coefficient, the estimates for beta 1 coefficient. You can see that it's a very large effect, so around 10 to 11 homicides per 100,000 inhabitants in our preferred specification, which is in column 3 here. And this indicates that municipalities exposed to illegal gold mining actually observed after the deregulation an increase in homicide rates of 10.9, which is huge compared to municipalities less exposed to illegal gold mining. We see also that these effects are robust to including state year trends and covariates interacted with year trends, and also when we are considering only the municipalities with gold deposits. So it's quite consistent over different specifications. When we're looking at the event study, as usual, we do not see any evidence on pre-trends happening here or driving the results, and we see that the effects are stable and persistent over the post period. So now let me just try and explain a little more about the decomposition of homicides by type. So here in this table, we are showing homicides. So the first column is our baseline specification, and then we're analyzing where these homicides are coming from. So we see that the most part of the effect is driven by homicides of male victims, On this column 5, we see that this effect is coming from male that are being killed outside of their homes, and for homicides that are committed by firearms or knives. We check also other dependent variables. For instance, in column 7, we are checking whether assassinations related to land conflicts increased more in those places. So as an alternative explanation for what we're finding, maybe protected areas are associated with, the presence of protected areas are associated to more land conflicts, and this could be driving our results. That does not seem to be the case. Maybe the deregulation led to more gold being sold in those areas and increased the presence of police. And because of that, it could have increased law enforcement and the police killings, and that's not happening as well. We do a bunch of other exercises. I won't go into details here because otherwise I think I have time? Okay. So the first exercise here, so let me go through the table better. So as usual, first column is our baseline. On the second column, we do the best that we can to make a measure for an intensive margin type of treatment. So here we are using for each municipality the share of deposits that are inside protected areas as our measure of exposure instead of using a dummy, and we see that the effect is stable. On the third and fourth columns, we are testing whether the presence of other types of garimpo minerals affects our results, and as you can see, it doesn't change. In this fifth and sixth column, we are basically interested in showing that our effect is not driven by the presence of protected areas per se. So in the first column here, we are only considering municipalities with protected area, and you can see that the effect is still there. And in this column, we are considering municipalities, the interaction of protected areas with our variable. So only comparing the exposure to illegal gold mining activities among municipalities that have protected areas. You compare municipalities where gold is inside them or outside of them. There could be also some concerns that the deregulation might be correlated with the discovery of new deposits or with the definition of new protected areas that might change over time. And so because of that, we stopped. So we are using a treated based only the protected areas and the deposits defined up to 2006. And we can see that the effect is still there. And finally, we are controlling for the presence of PCOs, which are the stores. So in this 8th column, we are basically removing municipalities that have stores, and we see that the effect is still there. So this tells us that the effect seems to be driven up by violence that happens in production sites and not where the gold is being sold. Sorry, it's not there. Back. Yeah. So lastly, we only have information for other types of violence for Pará state. And that's because there is the only state that produces information, detailed information on crime for this period. And we can see in this table that after the deregulation, body injury with fatality also increased in exposed places. Also, sexual assault increases and robbery as well. All of those types of violence are consistent with what we would expect if we have gold mining, more illegal gold mining activity happening. We also done a bunch of placebos. For instance, we want to check whether the gold mining activity is increasing income in the region and there is more migration coming to those regions, so we would expect to observe more death associated with more people being there. We do not see any evidence on that. These municipalities are not experiencing a differential and abnormal increase in their GDPs, in the mortality rate for other types of reasons, such as infectious diseases, circulatory diseases, respiratory diseases. And we also, as I mentioned before, we have made some robustness. All of our results hold when considering the sample of municipalities that have gold deposits, or the full sample with all the municipalities, not only those small municipalities with less than 200,000 inhabitants, and also are robust to spatial correlations like Conley errors. So let me go through this part here. We so far showed that the deregulation caused violence to increase in places more exposed to illegal gold mining activity. And our hypothesis is that the deregulation led to an expansion of illegal gold mining activity, and this produced the violence. So we need to show some evidence that the illegal gold mining activity is actually increasing after this deregulation passed. The challenge is there is no measure, no direct measure of illegal gold mining activity, right? So what we are using here is data on deforestation linked to gold garimpo from Mapbiomas. They produced this data based on satellite image and some models of identification of those types of deforestation, different types of deforestation, and they can actually classify what deforestation is linked to gold garimpo. And we'll apply a similar difference in difference design, changing our outcome variable to the share of deforested area by gold garimpo. And as I mentioned before as well, we are using a smaller unit of analysis, which is a 3x3 kilometer cell covering the entire Amazon. So just to make it clear, for instance, we had this map for controlled and treated municipalities. Here we are zooming in on one single municipality and divided it in its squares. And you can see there are some squares that are more exposed to illegal gold and some squares that are less exposed to illegal gold mining. So when analyzing the effects of gold mining on deforestation, we can see that there is evidence on an increase on deforestation associated to illegal gold mining after the deregulation passed. And this suggests that, that actually our mechanism or the illegal gold mining activity is also picking up after the deregulation, and this caused violence to increase. So to conclude, in this paper we investigate the effects of decentralizing monitoring strategies against illegal mining. We show that homicide rates raised very much in places exposed to illegal gold mining after the deregulation, and we show evidence that violence seems to be related to this illegal gold mining activity. So our findings, they will basically raise caution for these types of policies, such as permits or certification, where you're trying to decentralize monitoring, but we show that it is crucial for these policies to have a credible threat for the buyers of the products, for them to make their monitor of the activity. So if you have a certification policy in place and this certification does not put a credible threat on the buyers, it will probably fail in curbing illegal markets and its consequences. Thank you all. That's it. I don't know if I ran. I'm sorry.
Fiquei, eu tava achando, eu tava com... Tava de... É que eu olhei uma hora e achei que já era 40 minutos.
Okay, so Nice presentation.
Thanks.
Congratulations. I've been following
little
this
bit
paper
nervous.
for a long time. Like we've talked about this paper before. I've seen this paper being presented, and I've seen this paper growing. The paper is this thick because
Oh
it
my
has a
God,
lot of
you're trying.
robustness and mechanisms, and there is a model. When I see a paper with the model in the appendix, I know that there is a lot of things going on here. And so I'm really not trying to, what I'm trying to do here today is not to suggest many more robustness checks. I think you guys are doing the best you can with all the data constraints. And I would just like to highlight that I really like this paper because this paper is really close to public policy. So this policy was implemented, and you have a clear picture of what was going on. So I really like this on the paper, that it's really close to public policy. So I was trying to read the paper as referee number 2 would read the paper, so it's kind of annoying, but just trying to help you guys. So I think the paper has a very convincing story. Just look at this figure. Like, something is going on here, or Brazil has observed the highest possible productivity in an industry, which I think is amazing. But I think what is going on here, as I was reading the paper, is that the framing of the presentation is the framing of the presentation. So the framing of the presentation is much better, I think, than the framing in the paper, because in the introduction of the paper, you guys give a lot of, you really highlight the natural resources aspect of the paper, and I think this is not the main point of the paper. There's nothing that is specific to the exploration of gold here. And so, for example, the first phrase in the first paragraph of the introduction indicates illegal exploitation of natural resources, and then you cite some papers on the exploitation of natural resources. But I don't think this is, I think the paper has a wider scope here, which is regulation of supply chains in an environment with weak institutions, weak enforcement, weak property rights. And I think this has a wider scope than how you are framing this in the introduction. And I think this is important because I learned about reading this paper about things like to what extent can regulation overcome these weaknesses. So how can I design regulations that can overcome weak institutions and property rights? And where should this regulation be applied along the supply chain? So for example, this is a very nice paper from Tomás, and it is about the deforestation in the Amazon, but on the first paragraph, he's giving a lot of attention to policies that are easier to implement, to enforce policies that you can enforce in a concentrated supply chain. So that's I think you should take a look at this paper and how they try Tomás tried to frame this idea of regulation in the supply chain. And I think this can be important for cattle ranching, for example. You're tracing cattle, and you have carbon markets. That is kind of a market that is eroding exactly because the supply chain is complex. So I think you could try to frame the paper in a different way instead of trying to sell this as a natural resources paper. And I think this is kind of my main comment, because I knew the paper already, but it was the first time that I really sat down to read the introduction, and I thought that, okay, the introduction is different from what I was expecting. Okay, the empirical challenge that I see here in the paper is that what is so special about protected areas here? So you have a bunch of robustness where you exclude protected areas, for example, so you use gold permits to understand where there is illegal gold outside of protected areas, and then you find 0 results there. And the way the paper is written, it's kind of it turns down the reader a little bit, because you have all these results for protected areas, and then you show the results without protected areas, and it's always zero, the effect. So I think it would be good to don't let the reader figure this out for themselves. Just try to explain a little bit more about the local context and what is going on here, why the results are only present when we have the sample with protected areas. And I think this is just a problem of variation in the data. You have this huge municipality in Brazil, and you are mixing legal and illegal gold, and when you have data within protected areas, you are sure that this is illegal. So I think it would be good to have first more of a discussion on why protected areas and why this variation is important, but also more of a discussion of why you are finding the zeros effects and not highlighting these as a problem, because I don't think this is a problem. I think this is just a matter of variation in the data. Okay, so I'm not asking you to add more pages in the appendix, but this is my final comment. So on the deforestation specification, I didn't find it in the paper, but maybe you could just compare cells within protected areas, because that's kind of the problem, right? You are comparing cells outside and inside protected areas. So maybe just have a specification where you are comparing protected areas with protected areas. And then this problem of pre-trends, where you have to control for the share of protected areas, then that just disappears. And I think it makes for a clear picture of what is going on. And I don't know, maybe this should be the main specification, because when I was thinking about the paper, this is the specification that I would try to run, like the first specification that I was going to try to run. And also on homicides, and this again goes to this matter of data variation, why not just compare municipalities with and without gold? Because, okay, I have pockets of legal gold exploitation, but I can think of cases in which you would have illegal gold exploitation next to legal gold exploitation. And so maybe just compare municipalities with and without gold, without this triple interaction. And I don't know if this would make more sense, and this would help you to understand where the variation is coming from. So I think that this is it, and I think that this paper is amazing, and I hope it gets published soon. Thank you.
Thanks. Thank you. Leila, do you want to comment to anything?
Just to. Yeah, I can reply some of your points. The first one is, yeah, it's difficult to frame it. There are many possibilities we're trying, and maybe you're right. We should go on this way. You mentioned here, I forgot. Yeah. So for this last part here that you were mentioning, we actually had that test on homicides comparing only municipalities with and without gold deposits. It was on our appendix, but we removed it. So we can add it again, and it's actually increasing in all places with gold, but it's an increase more pronounced in places that are exposed to illegal gold mining activity, and that's why we decided to exclude it. So I don't know, half I have, yeah, that's it.
The paper has 90 pages, I believe. So maybe 100 is the...
We are really trying to shorten it, but every time it goes to a journal, there are many possibilities of heterogeneities, and so, yeah.
All right, do we have any questions? We still have a few minutes. All right.
So I think this is a fascinating paper. I think the results are really striking. So I'll offer a comment and then an idea, which is not the idea is not for this paper, but maybe for sort of a subsequent paper or something like that. So I'm not suggesting you add it to this paper. So the comment is, I find it really interesting to think about the parallels between this setting and actually a paper that I wrote, a while ago about diesel fuel tax evasion in the U.S., where you basically have taxed and untaxed sources of diesel, and there was a period of time where criminal organizations would basically buy untaxed diesel and then create a paper trail and sell it to a retail station as taxed diesel, basically make it very difficult for the retail station to audit that this was actually sort of illegal diesel or diesel on which taxes had not been collected. And so it makes me think a lot about sort of the interplay between, the illegal and the legal market for gold here, and think about sort of to what extent were sort of illegal deposits being funneled into, sort of mixed in with legal sales in sort of the pre-period, sort of even before this was happening. Because it seems like, if I were thinking about how, if I wanted to sort of deceive one of the PCOs and I have, some illegal mining deposits and some legal mining deposits, what would prevent me from just sort of funneling those through, funneling my illegal gold through the legal deposit, and it just looks as if my legal deposit is especially productive. But I think it's a fascinating paper. The other idea I had is thinking about sort of illegal versus legal sources of natural resources. You could imagine that there's essentially sort of a supply curve for illegal gold and a supply curve for legal gold that might have different shapes, right? One of them might be more steeply sloped than the other. And I wonder a little bit about whether there's something interesting to say about, as natural resource prices on the world market rise and fall, how those two margins sort of respond, like whether you see sort of an increase in illegal gold relative to legal gold or sort of vice versa. But it's a fascinating paper.
Thank you. Thanks for the comments. For the first part, we actually have evidence that there was gold laundering happening before. So, of course, we have miners that are disguising the origin of gold before, as you said. And what we are thinking that is happening here is that you are adding an extra push to this activity, because now the PCOs, now you have evidence that the PCOs themselves are working to launder gold. So there is some PCOs now that they have like one permit where they are simply putting things there. This is very anecdotal, so so we story on that. And for the second part, I don't know. Sorry, can you repeat the second part?
I was just thinking about sort of there being
different supplies. Yeah, we actually control in our specification for the interaction of international gold prices with the presence of protected and protected of illegal, with the exposure to illegal gold mining activity. And our estimates, our final estimates, do not change much. They increase a little bit, so we do not think there is much difference happening there. Yeah.
Right. There was another question over there in the back.
Very short question is whether is any robustness check for the land-related conflicts, because that's many homicides there in the Amazon. They are driven by this force, and it is greatly protected areas because there's some violence around the boundaries of protected areas. And even if you clear out the possibility that you have like a pure protected area effect with robustness that you show there, the penny variable still can capture some of these land-related conflict homicides. So maybe if you can compare like periods that were created well before 2013 with those created in 2013 or afterwards, maybe you can make more sure all the sides are not capturing these play violence, play conflict.
Thanks. So let me understand let me check if I understood you correctly. Because in our tests, one thing we do for controlling for land conflicts. So the first test that we did was to use Comissão Pastoral da Terra variable as a dependent variable, the land assassinations related to land conflicts. So we use that and as a dependent variable in the same specification, and we show that there is no evidence of this type of homicide increasing. It's kind of tricky to do that because there are less observations than homicides through the Amazon, so we would expect to see something small, but the fact is we do not find any significant effect. And for the presence of protected areas, I think I was fast when I show that. We actually do two robustness. The first one is to select among municipalities with protected areas, and then just to try and separate these effects. So if there was a land conflict related to protected area, then by comparing municipalities that among municipalities that have protected areas, those that have gold deposits inside protected areas with those that have gold deposits outside protected areas, then we would be controlling for like this baseline type of municipalities or exposure to land conflicts that are associated with protected areas. And because of that, we thought that we were controlling and analyzing this type of concern, and we show even that if we interact protected areas with our treatment variables, both the presence of gold deposits and the presence of gold deposits inside protected areas, we still see that the effect is dominated by our exposure measure, which is the presence of gold deposits inside protected areas. But then you suggested something that I don't know if it's different from that, and that's what I was trying to, it's not different from that?
No, I think that's already enough.
That's enough. So it was my mistake that I wasn't clear in the presentation. Thank you so much.
Any other questions? Yeah, sure.
Great paper, so it's hard to add anything. Can you say a bit more about how this law was passed in 2013? Was it announced in 2012? And then also, for me, the homicides seem to already go up in 2012, but there could be a story that if the law is announced in 12, that people are starting to sort of, put down, the violence starts to put down where I'm going to start the illegal mine or in the next year and so forth.
Yeah, sure. That came out also on some reviews from this paper. And the story is the following. People from financial institutions, so this is anecdotal, we don't have proof for that, but both people from financial institutions and from the National Gold Mining Association were worried with because they were being prosecuted before the law passed. And they were actively lobbying Congress to move this deregulation in some way. So people working in the gold mining industry were trying to move the law. And this is according to the Federal Prosecutor's Office in Brazil. They said actually that there were members of the financial institutions and also from ANORO, which is the Gold Mining Association, trying to move this law. And the first evidence of someone trying to move the law is in December of 2012. So they tried to put these amendments in another law, but they couldn't. And then they finally adjusted the amendments in 2013 in the middle of the year, so in July of 2013. What we argue in the paper is that they were already working with that, so they knew precisely when the law passed and started right away. So the thing changed in 2013, not in 2012. There's maybe it was on the descriptive plot because it's joining. Here. So what we see is that it picks up in 2013, but as this is annual data, here both of them are really close, and then it picks up. Yeah, and if you look, the evidence on that is basically the event study, right? The event study is confirming that things are picking up in 2013, and the point is, everyone knew and everyone was working towards changing this deregulation. And lastly, on anecdotes on the regulation, this law, these two amendments were actually excluded from the Brazilian law last year because in the beginning of the year, in January, there was like this huge crisis with Yanomami people in Roraima. And this was basically because of the presence, the massive presence of gold miners inside indigenous territories that were bringing disease and harming the environment and making it much more like probably impossible for indigenous communities to live there. And because of this crisis, at the beginning of the year, the Supreme Court in Brazil removed these articles from the law, so very recent.
Any other questions? If not, we are just in time, so thank you very much to the presenters. I believe we pause for lunch now?
Yeah.
Okay.
Okay, thanks. Okay, thanks a lot. We have 1 hour for lunch, and 1 p.m. we rejoin here. We have the poster session. Stephanie will be around to show us her poster, and see you after lunch.
Did you manage to plug it in?
I think so. I think it's Stockholm.
Can you try? Okay.
Hello, everyone. Welcome back to the afternoon sessions of the Economics of Low Carbon Markets. It's a pleasure to have with us today Wolfram Schlenker. We've originally invited you, I don't know if you remember, we originally invited you for the 2020 edition of the Economics of Low Carbon Markets, but something like COVID happened, and then we didn't have that year. And then when we get back here in Brazil, we have the pleasure to finally meet you in person. And Wolfram Schlenker is the Ray A. Goldberg Professor of the Global Food System at the Kennedy School of Government at Harvard University, a research associate at NBER and CEPR, and he holds a PhD in agriculture and resource economics at Berkeley. And without further ado, Wolfram.
Thank you. Thank you so much for having me. I'm very glad that I could finally come down. So this is something new I've never done before, but when we talked, this is supposed to be more of an overview of covering 3 papers. So these are 3 working papers. So that's why there's so many authors. They are from different papers. I will go through them, and hopefully I can sort of link them a bit together. So what I want to do here is I want to sort of the end paper is sort of about the incidence of a carbon tax, and what I want to try to I shouldn't say convince, what I want to try to raise is that economists really believe in carbon taxes and think, just by price signals we can induce huge amount of CO2 reduction. I'm a little bit more wary, given the scarcity rents and inexhaustible resources, that a lot of it is just being taxed from producers, and we actually don't see much of a CO2 reduction. That's sort of the pathway where I want to go. So the University of Chicago has this nice standing panel of economists that weigh in on current policy debates. So what you see here under EEP is sort of what economists do, and then there's also sort of a general survey of market participants. And so economists all agree 100% that it's hard to predict the stock market with like 0% uncertainty. So one thing we agree upon, but one thing that's striking is if you actually look at the question, where's the largest discrepancy between economists and the general survey, is down here for carbon taxes. It's a 70% swing. So economists think, like 93% of economists basically say, yes, carbon tax, best way to go to reduce CO2 emissions. While in the general public, people are much more open to sort of technological standards and so forth. And so where does this discrepancy come from? So the 3 papers I'm trying to cover, I'm going to speak fast so I can cover them all, first is sort of a more theoretical model that I'm doing with the first 3 co-authors, so Ivar Eklund, Brian Wright, and Peter Tankoff. It's a bit of a revised model of hoteling, but the hoteling model is what I need for the other 2 papers. It's sort of trying to explain for why we haven't seen price rising as much as the standard hoteling model basically suggests. And our big sort of pitch there is it's all about endogenous discoveries, that when the price gets too high, you start looking for new stuff and you discover it. So then using this model is sort of the most time I'm going to spend here in this talk is on the 2nd paper. That's with Maya Norman. She's a PhD student at Columbia. Then we look for empirical evidence of the green paradox. So the green paradox is nothing new. It's this idea that if climate legislation limits how much we can use fossil fuels in the future, and since this is an inexhaustible research with a finite amount available, we just can't use it in the future, so we use more of it in the present. But what we want to do is sort of provide some empirical evidence using prediction markets and all future returns. And then having sort of established that, hopefully you buy this, that the market responds to those signals very strongly, trying to implement what would happen under a global carbon tax. So the very important thing here to notice, we're talking about a global one. If you have local ones, it changes the local price, and it has really been measured to have a sizable effect. But for this to be effective, it would have to be global. But once it's global, it's much harder for producers to pass this on, because then we don't use up all the oil reserves anymore. So that's where we want to go. So just quickly on this first paper. So, limits to growth in the 1970s sort of predicted that we would run out of oil by now. And here what you see actually in the red line is sort of the amount of proven reserves. This is from a BP annual reports. And the notable thing is exhaustible resource known reserves should go down over time, right? Because we're using up, we have a finite amount, we use it up, so the red line should be going down over time. And if you calculate sort of the ratio of current use to stock, you realize how this is remarkable constant over time. So the unique thing is that even though we used a lot of the production here in blue, which is larger than what was available in reserves now, we actually have higher reserve stocks now than we had in the 1970s. And that's because there's been so many new discoveries and enhanced techniques to basically explore this thing. So what we're doing in this model, and I don't want to go too much in sort of the math details here, is a very standard model as an extension from Aaron Chang in '82, where there's two countervailing forces. You basically have unexplored area where you can look how much oil is in there. It's just standardized. The important assumption here is exponentially distributed, how much land you need to find the next resource. So it is like memoryless, it's very nice mathematical, like past exploration doesn't impact future one. The other big assumption which we follow them is that there's constant marginal exploration cost. So to look is the same for every land. And given this memoryless and the constant marginal one, you basically get a bang-bang solution in the end, where you basically look at two different factors. On the one hand, I would like to know how much oil I have in the ground right from the beginning, because then I can optimally allocate it over time. On the other hand, I don't want to do the exploration, which is costly, because if I do it later, I can basically discount my costs. Intuitively, if I have lots of oil on hand, I'm not looking anymore because I'm kind of safe for now. And then at some point, the oil reserves get too low, and I start looking for this, and then you get this bang-bang where you just explore. And so if you then this is a simulated price path here. So this is basically the standard sized reserves that you find. This is here on the x-axis is how much you have unexplored. You start here with the standardized one until everything is explored. And on the y-axis, you have how many reserves you have. So you start, you just consume until you hit this critical level here, then you explore, you find the first reserve, you consume again, you start exploring again. This is the exponentially distributed one, you jump up again. And you see here, you take so much area until you find the next one that you're still under it, and you immediately start to look for the next one again. The only thing why this is sort of important is because you get this really, and I skipped this, what's nice about this price path is when I was in grad school, there were two sets of tests. The forward-looking hoteling test, like Miller-Upton, which doesn't fail, and the backward hoteling test, which sort of Harvison and Smith, that failed. And this model can sort of reconcile the two, because in expectation, the price always rises at the rate of interest, but you have a highly skewed distribution of possible outcomes. Basically, if you don't find anything anymore, it would be a huge surprise with a huge positive price jump. On the other hand, with a very high probability, you basically find something and your price drops. So what you see here in pink is actually the price path that is conditional on not having run out of unexplored area yet. So again, this expectation here is basically driven completely by this small probability that you're running out, which is completely unexpected. But it's kind of sort of explained by realized price path in a hoteling model that even rise in expectation at the rate of interest, in exposed often actually don't show this, this rising rate of. So we can sort of simulate those, and you also get the reserve stock, which sort of captures more what's going on in the real world. So that's sort of the first paper, sort of just trying to emphasize how important endogenous discoveries are, and that the hoteling with the arbitrage conditions still holds. And so I'm going to use this now in the second paper. So the idea for that paper is, and again, this is nothing new, this green paradox has been around for a long time. It's this idea that if we put climate legislation into the future, I mean, there's good reason to do it in the future. Like Rob Staven has written a lot about the Kyoto Protocol, saying it's too little too soon. So this idea, we need to have something strong, but we want to do it farther in the future, thereby giving companies the incentive to adapt and change their behavior and so forth. So the EU wants to be, carbon neutral by 2050, China by 2060. But again, from this hoteling model, how you optimally allocate it over time, you sort of have then this idea that you might accelerate something forward. And so, Saudi Arabia extracts oil at $8 per barrel and then sells it for 70. So they have a huge scarcity event in there with the potential to lower their prices and still make a profit and continue to produce. And so this is then this idea of shifting from the future to the present. And just to give you here a very simple example, so this would be the optimal quantity under constant demand that's just isoelastic over time. Then Vaxen Market, which is the US climate bill that was discussed in 2009, 2010, which we're going to examine in this paper, basically limited oil use from 2050 on to be 83% of the historic one. So you basically here limit it to 17% since you have to go 83 production. And so you realize that there's this area A here, which you can no longer extract that you initially planned. And then so under the green paradox, you basically just reallocate this area by accelerating some of it forward and some of it more at the back end, but using all the oil is just differently allocated over time. And you can actually, in a way, make the problem worse through our climate legislation in the future if you give those producers incentive to produce more right away. The motivation I showed you here is very simplified. So Ryan Kellogg and Soren Andersen and Steve Soland have a really nice paper that's much more real-world relevant. So basically what they do is they have well physics in their paper. It's called hoteling under pressure. The idea of that model is that once you tap a well, it just keeps flowing. You don't close it. You know, in hoteling, you arbitrage by either doing it now or tomorrow when I produce. But once a well is actually tapped, it's very costly to close it, so you just let it run. So what they show is that the new drilling responds to prices, but existing production doesn't. I mean, the best proof of that one is that during COVID, the price was briefly negative. So producers actually paid you to take their oil because it's so costly to close the well. So that can lead to some sort of shorter run dynamics, which are sort of different, where you basically, you know, the standard hoteling model doesn't apply one for one. The other thing is, in this example, is that the demand for oil that I just showed you is constant. As GDP growth, so does the demand for oil. Part of the reason why we've seen this outward shift in demand is just that we've grown, which is a good thing, and so, but this sort of is held constant here for now. There's obviously a big uncertainty about what's going to happen to demand for fossil fuels in the future, given that we're doing heavy investments in renewables. So there's another current paper by Ryan Kellogg that sort of looks at, called The End of Oil, that sort of thinks about phasing out oil. And so one of the, I'll come back to this later, I mean, he also has an initial price reduction to what we find here is, but the big difference here is sort of what you assume about future demand growth. So in his model, it's basically that we have demand growth until 2030, and then we phase it out over 75 years to zero with a linear phase out. And in some sensitivity checks, if it's 15% of oil demand remaining, it doesn't work anymore. So we really have to believe that there's sort of this renewable coming online and completely reducing the demand for oil to make this model work. And so, yeah, this is sort of what I put here. And in this model, so it's very interesting. In a way, I hope it's right, because from a climate perspective, this is a much more encouraging thing, because in this model, what basically happens if demand collapses and there's really high interest rates and there's upfront costs to set up a new well that then continues to run, the green paradox doesn't apply as much anymore. That basically means you can put on regulation even in the future, and basically the oil producers stop drilling. But again, it very heavily relies on this decrease in demand. If you have the 15% for like aviation or petrochemicals remaining, it wouldn't basically, you still use up all the oil in the end. Okay, so I'm not going to go through this really long theoretical literature, but just sort of some citations here. So nothing new. Some people have looked at empirical evidence for the green paradox environmental regulation before as well. What they often do is a pre-post comparison. I mean, it's a little bit tricky about reverse causality, because you can think, you know, if an industry is going out of existence, it's easier to pass an environmental law. And if I just do a pre-post comparison, it's sort of hard to know which one causes which. But these are some papers that have looked at that in more general environmental regulation, not just specific to CO2. The paper that's closest to us is by Derek Lemoine. He actually does an event study on when Senator Graham abandons the Waxman-Markey bill, so it's just one day. And so that's clearly identified. The one challenge in that paper is that it's exactly the week where Deep Horizon happened, and so there was a lot of disturbances in the oil market. He also announced it Friday night, so it's not really clear when the market updated. So we're trying to extend this and sort of do this with more data points and sort of look at the green paradox. So what we're doing in this paper with Maya is that we basically have high frequency daily data. So what we're using is the prediction market here. You know, if you could bet basically on InTrade on the probability that Waxman-Markey would pass by the end of 2010. And that gives you daily probability of this law passing. And then we pair that with daily oil future returns, not just for 1 month, but up to 24 months into the future. So we also have like the curve of across maturities. And then we sort of regress daily changes in prediction market and link it to daily changes in oil futures for all different maturities. So you have many more data points, high frequency, and we can do some more falsification checks than just having one date. We also redo some event studies. The two things we focus on is Justice Kennedy in the United States sort of signaling that he would support Massachusetts versus EPA, which basically gave EPA the right to regulate CO2 in 2006, as well as a court case in the Netherlands, Urgenda where the Netherlands, where an environmental group sued the state saying you have to do more about climate change, and surprisingly won. So that's sort of a surprise court ruling. And in the last section, we also do 4 decades of environmental salience and sort of find similar results again, but that's not as well identified. Okay, so that's sort of the idea of where I'm going to try to take here. So what data are we using? So very standard like financial data. We have the Western Texas Intermediate oil price. We have oil futures. The liquid ones that we found were basically monthly up to 2 years into the future. So on every single day, we have 24 data points for the different months into the future, how much the oil price is 1 month from now, 2 months, 3 months, all the way to 2 years into the future. And that's actually one of, I think, the strongest things that we have in this paper, that the green paradox is real. If you look at the paper, if you regress oil futures and changes in the oil price, there's sort of this curve where shocks basically phase out. This idea that there's some supply or demand disruption right now. So next month and 2 months into the future of the oil price is adjusting, but 2 years into the future, we're sort of not that highly impacted. Now, what you saw from the green paradox is you're resetting the entire time path. And what we do find here is actually that the 24 months future is the one that responds the most strongly to the shock rather than the 1 month one. So it's really phasing in, it's really resetting the whole path. So people seem to permanently adjust of what they're trying to do. We also do some sort of other minerals like copper, aluminum, and steel, and coal. It's all from the New York exchange. They don't all get traded 24 months into the future, so sometimes it's less than 24 months. And so this is the sample period we're looking at. So this is just oil prices over time. Again, here you basically see that during COVID, it was briefly negative because you couldn't like plug it, oil demand collapsed briefly. But our sample period, which is where the Waxman-Markey bill was discussed, is basically here from middle 2009 to through 2010. So you see the prices there didn't have like the humongous swings. It's sort of fairly confined over our sample period. The week and a half, not a week, a year and a half, sorry. And so we sort of used that. Then this particular intrade data that also Carl Meng used for a paper to look at the cost of environmental regulation is basically a contract that by the end of 2010, a cap and trade system for emission trading to be established by that date. So you can bet on that. And in an efficient market, the probability of that law passing should be equal to the price in cents. So 55 cents means on average you give it 55% probability. And so this is basically this Waxman-Markey bill. It had several provisions. One was the 83 I showed you, but there were also intermediate targets to sort of limit it. And initially it actually had a probability of passing of more than 50%. The Senate actually passed it. So the one house passed it. The House passed it, apologies. And it was discussed in the Senate, and it even had some Republican backers, notably Senator Graham. And then you see how those prediction market here moves up and down, and then eventually it sort of phases out over time. So what we're looking at is basically those changes in those prediction market prices and then link it to oil futures on the same day and sort of see whether the two are linked and whether they are aware of this potential of the climate law passing and the oil prices. Now, notably, this law was never passed, right? This is purely an anticipation effect, purely sort of speculating on the probability. We always control for the S&P 500 because, again, oil prices are highly sensitive to economic growth. And we sometimes also subset the data based on Google Trends just to make sure that people are aware of what's going on. So Google Trends basically normalizes everything to the day with the highest activity. So here 100 is basically the day with the highest internet searches in Google for Waxman-Markey. And 5 would mean it's a day that has 5% of the search volume relative to the highest day. Okay, So what are we doing here? It's a very simple regression. So you have like oil future prices for different maturities, F from 1 to 24 months into the future on a particular day. So that's the change in the oil price. We basically look at closing price relative to previous closing price. We have month by maturity fixed effects. So what that means, we're looking at one particular oil maturity, say 2 months into the future, and then only look at returns within a month. So there's tons of fixed effects because we don't want to compare two different sets and things might develop over time. Then we have basically the change in the price of the prediction market in there. That's basically what we use in an exploratory variable, which ranges between 0 and 100. So again, this is the probability of the law passing. Now, what sometimes people said is true. This is not a highly liquid market. So there's some, you're going to see this in a second. There's a huge mass point of 0 price change because no trading is going on. So what we sometimes do is sort of, on this sort of the baseline I'll show you here, is to basically have another interaction term which basically factors out the sensitivity on days where there's huge swings relative to days where there's minor swings. If you think that the market's really only paying attention when major things happen. So here this is basically looking at, so the baseline beta C is then picking up the effect on days when the probability adjusted by more than C cents, while the interacting term basically measures the difference to days that aren't as actively traded. And again, we always adjust for the S&P 500, and then since we have 24 observations per day, we cluster by day. So here are sort of the baseline results, and here is the different columns are basically different cutoffs. So 0 is basically the full sample, all days. This is basically 420 days that are in this May 2009 to December 2010. The weekends aren't in there, that's why it's sort of 420. And you see as you move to the right, the number of days that are basically above, meaning having at least this kind of change in the prediction market is sort of going down. So if you have at least 1 cent move, that's 118 days, 2 cent move, 80 days. The most stringent here is you basically change the prediction market by at least 5 cents. There's only 26 days left. But you see here that this baseline coefficient is rather robust across different specification, whether we use only the 5 days in it to define it, or we basically use all the days. It's roughly between 3 and 4%. And these are normalized to basically be from 0 to 100%, meaning from knowing the climate bill doesn't pass to knowing it passes with certainty. So this means that the oil price would drop by 3.4% if this law was passed, relative to if the law wasn't passed. So it's sort of a significant and sizable reduction here, sort of irrespective of the column we use. So one of the feedbacks we got as well, is the climate bill just limiting future growth? And since future growth impacts oil demand, are you just measuring sort of a choke-off of demand? And one thing the referee suggested is, well, look at other minerals. So that's what we have here. So this is basically the same thing I just showed you before, except that in the baseline specification, we allow the S&P 500 coefficient to vary by futures maturity. And here we have one common one to sort of highlight how much it depends on the S&P 500. And so you see this 0.84. So if the S&P 500 goes up by 1%, oil futures go up by 0.84%. And again, you see sort of this effect on the oil market. Now, on the other hand, if I go to copper, you see it has exactly the same sensitivity to S&P 500 as the oil, but there's nothing significant here. And if you think it was the demand channel choking off demand, we should see sort of something similar. For aluminum, it's less related to S&P 500 because there's less scarcity. The coefficient is now sometimes even positive rather than negative. And then steel is basically something where there is not even a correlation with the S&P 500, which you at first might think, why is that the case? But for oil, we have about 50 years left. For steel, we have about 70,000 years left of iron ore. So it's just much less scarcity, so it's less sensitive to GDP fluctuations. In a way, those sensitivities to S&P 500 is sort of already giving you a little bit of the green paradox feel, because it means as the economy is growing, the market readjusts and sort of knows where demand goes up and down and how the prices respond. But so it doesn't seem to be driven by just the drop-off of economic growth, because we don't see it for any of the other exhaustible resources. The other thing we can do is sort of similar to what you saw in the first talk here today. We can purposely do a one-day offset. So again, this is the baseline where you see that it's basically significant around 3 to 4. If we just use from this daily data 1 day ahead, delete, the results completely go away and results no longer are significant and have like no significance. The notable thing here is also if you're worried about reverse causality, remember in this one with like 5%, that's 26 days. So if you look at the paper, what we basically do is we list those 26 days. And the reason why the market moved a lot of them those days is because it's basically when committees in Washington, D.C. met, and then they basically either broke down or they basically passed a certain legislation. It's almost impossible for me to think that a committee is scheduled 3 weeks in advance in anticipation that we will have an oil price movement on that day. So, you know, but oftentimes in this literature we have the reverse causality, given this day-to-day fluctuation and not having anything the next day makes it much less likely. These are basically major events driven by pre-scheduled policy announcements and therefore much less prone to sort of endogeneity. Okay. So another thing you might worry about is, you know, is this just driven by outliers or how much is it symmetric for, we had this in the first session too, whether you have an increase in the probability or a decrease. So what we do here is basically we just don't assume anymore the linearity, but just have the restricted cubic spline with 5 knots. So you see here, there's this huge Mars point at 0 in the density of, these are basically the daily returns on the prediction market. So many days it just doesn't change. And then you see here is where the changes occur. And this is basically the response function. Now the question is, do you think this is sort of linear or not? So if you're in this small area -2 to 1, you know, it's often discrete numbers. So most of the prices, even though they don't have to, but most of the prices are in integer numbers. So there's sort of a bit of an integer problem. So in there it's pretty flat, but the remaining area seems both symmetric and linear if you squint enough. So it doesn't seem to be driven by any outlier, or seems to be symmetric for increases in probability and decreases of probability of the law passing. And then finally, I think I mentioned this already, instead of just estimating one average return for all oil futures, we basically estimate it by maturity. So basically the different columns of the table before are now different colors here. So you know the table I showed you before was basically the average effect across all maturities, and the different colors here are just the different columns, the cutoffs on how many days we use in identification. And now you see on the x-axis here the month into the future. And this is sort of what I showed you before. It's sort of this remarkable fact that it actually phases in, meaning the largest effect is 24 months into the future, while the 1 month doesn't actually respond as much. This is sort of consistent with this Anderson et al. Paper on, you know, the physics. You can't just increase oil production right away. You need to drill a new well. That takes time. So that's why sort of it's actually encouraging that sort of the longer term effect is sort of larger than the shorter term. Because this is very different from sort of the standard. If you look at the persistence of shocks, which is sort of just doing the same thing with an oil price shock, you see again how initially most oil price shocks completely phase out. And this is basically during the time when the climate bill is negotiated. You showed it. It has a much higher persistence because it's by the fact that it resets the entire price path. Okay. All right, so another thing we can do is usually when we have supply shocks, we see prices and storage move in opposite direction. So, you know, storers basically store if they think the price in the future is higher than the price in the present. Now I showed you that the prices in the future are adjusting more than the prices in the present, which means that storage becomes less profitable. And so if you look at this here, we only have storage level data not on the daily level, but at the weekly level. That's why the number of observation goes down from 420 to 85, because it's now per week. But you do find that when the probability of the law passing goes up, not only does the price drop, but the storage level drops too, which is again a very strong signal, because usually when prices drop, storage levels go up because we buy cheap and sell high. But this is basically telling you just want to increase current consumption. How do you increase current consumption? You lower the price, and since you haven't ramped up new production yet, you basically lower the storage level and start selling the stuff off. So it sort of goes in the same direction as well. It's not always significant, but with the Google price data here it's not, but goes in the same direction. I don't have a 90-page paper, but a lot of sensitivity checks you can throw at it. You can sort of look at only high volume days where it's traded more actively. You can basically do different clustering. We use the most conservative one. All the other clusters give you more significant, higher significance levels. You can have sort of the curve on the S&P 500, the expectation in there, control for oil spot price. It doesn't really change anything. I also mentioned we did sort of those two court cases. Those two court cases are basically Kennedy signaling support, and then there's a Netherlands ruling, and there's also a negative abnormal return on those days. If you're sort of worried about reverse causality, these seem to have been surprises. It's also important to show you how it's the anticipation that matters when new information gets revealed. Because we go to Google trend data on like EPA versus MA versus EPA. That Supreme Court decision was actually decided in 2007 in April. But the futures market prices and the interest basically spiked when in December he gave an interview signaling that he's going to support it, and he was the swing vote in the 4-3 decision. So the market doesn't respond to when a verdict is announced. If they already know in advance, it's likely to come down. It's sort of when the new information is being revealed. And I very briefly mentioned this before. This is sort of a completely different data set. This is sort of a new thing where you have 40 years of data, where you classify environmental policy stringency by, for climate policy, for renewable policy, and for overall environmental policy. It's done on a monthly basis. So now we don't do daily, but we do monthly. So it's basically month-on-month oil futures returns. And we link it to this policy index about how much adjustments there have been on policy discussion. We basically include year fixed effects or quarter fixed effects. So even though it's 40 years of data, we basically just look at the returns within either a quarter or in a year. And you do find that the climate policy stringency index from there is also negative and significant, while the other two are not, which you would predict with the green paradox. So they all point in the same direction. So if I have you somehow convinced that this might be real, we can sort of do a little bit of back of the envelope on the magnitude. So just using the literature, that's sort of the elasticity, the long term is about minus 0.6. And if you use the baseline estimate here from the first column of minus 0.344 of using the entire data, it would mean that if the law just for the US had passed in 2010, oil consumption would have gone up by 2% globally, not just the US, because this is a global oil market. So it's sort of a bit of an offset here. Now, one thing I have to be very careful if you want to, yeah, you have a question?
May I ask a question?
Sure.
How important was the lobby of the oil industry to influence the prediction markets and the passing of the bill, or not passing of the bill?
Oh boy, this is a lot of anecdotal evidence, right? So I think there was actually a good chance at some point to have passed. The New Yorker has a big essay about why it fell apart, and I don't have any sway on that. I wasn't part of the negotiation, so I can only recite what they said. But I think, as I said earlier, Senator Graham from South Carolina supported it. I think in large part because they have a lot of nuclear power plants down there, which would have basically been good for them, a carbon tax. They don't really have high, they wouldn't have to pay anything for that. It had a lot to do with, there was the Kerry-Lieberman-Graham coalition to sort of push that through. They passed some other law that they were upset about and then sort of unraveled. So in that paper, in this New Yorker article, it's not attributed to strong lobbying. It's more like interpersonal animosity. Apparently the head of EDF was basically telling Graham, I'm gonna give you campaign monies from my donors to sort of withstand the weathering storm that you will get if you pass it. So I don't think it was because of the lobbying, according to this article. But again, I wasn't in the room, so I don't know how efficient they were.
You had lobbying in both sides too.
Sure, but I think the renewables back then wasn't that strong in 2009 and 10. I actually do think that, this is just my very wild prediction, but he was actually running on it. I think if Obama had lost to, I'm blanking on the name, in 2008, then to John McCain, we would have actually gotten the carbon tax because the House was Democratic, they were in favor of it in the Senate, and if the president would have pushed more, that was from the sort of Republican side, potentially could have passed. But one thing that's important here to notice about the market expectation, we are only evaluating this trading that the law passes by the end of 2010. The market might still think you pass it in 11, 12, or 13. So this is sort of the adjustment you make that the law didn't pass by this endpoint. But net of potential future ones, and also net of the effect that the US passage would have had of China passing it and so forth. So this 2% is sort of a funny number because to look at how much this means in real reduction, you need to have all this net on expectations in the market where there's no contract for it, so we don't know it. So we can't push this too far in sort of what it would imply for reallocation. Okay. The other thing to emphasize is there's more and more paper how uncertainties itself and regulation can have an effect. So if you look at, again, at this price path here, where you had like 55 cents at some point and then collapsing, you can use now the short-term elasticity of Hamilton of 0.26 and basically multiply this times the probability of this law passing, which then means how much oil consumption should have gone up while the oil, while this bill is being debated. And if you then add this up over this year and a half, you basically get 3.6 days of global consumption that were extra consumed just because there was uncertainty whether this passes or not. So even anticipatory behavior can have sort of an effect here. Okay, there's a couple of limitations of this paper. I don't want to push it too far with its knock-on effects. I think one of the saddest thing here is even though we have the 2-year phase-in, which I find very strong, we don't have any more futures data beyond 2 years. And for the whole green paradox, it's sort of really important how much prices develop beyond the 2-year frame, and I can't really tell you anything like that. And that sort of comes back in where sort of Ryan's paper comes in. If demand starts to collapse in 2030 and onwards, then it sort of might be a very different story. This is the global oil demand though, and you see how it's grown continuously except for certain recessions like in the 80s and then now during COVID again. So it's just hard for me to assume that from 2030 on, we're going to collapse to zero when we've been marching almost monotonically upwards of this for so many years. I hope we can, but it's sort of the tricky thing. Okay, that gets me then, unless there's other questions, to the third paper. This is with Jeff Heel. And basically what we wanted to do there is basically to sort of simulate the effect, again, of a global carbon tax, not of local ones. So there are those cool papers which basically show the effect of local carbon taxes. The forthcoming one from Jonathan Colmer and co-authors in Europe is really cool, where they look at the EUTS, pairing firms that are in EUTS to ones that are not, and look at their emissions over time and employment. And so they don't have much of an employment decrease, but they manage to reduce CO2 emissions, partly by getting more efficient. So it seems that the EUTS has a measurable effect on CO2 emissions in the EU. But again, for them, they pass on the prices, and it doesn't impact the global prices much because you can still sell your oil to China or the US or something like that. Similarly, Metcalfe and Stock have sort of a macro paper on carbon taxes in a panel around the world and look at employment and CO2 emission. And again, find no evidence that it has negative employment effects and a little slight positive effect on meaning CO2 reductions. And so we are sort of focusing on this hoteling model, how you reallocate things. So in terms of, I'm going to skip this theory here. The important thing to note is the optimal hoteling is if you have now different cost reserves. We're basically using a Rystad is this big engineering firm which has well estimates of how much it costs to produce oil from various wells across the United States. In the optimal hoteling model, what you should actually do is you start with the cheapest reserves. Then this scarcity rent here, the H, is basically rising at the rate of interest. Then when you depleted this cheap reserve, you switch to the next costly reserve. And you see here how there's sort of a kink, but not a discontinuity. Because of arbitrage, there can't be a discontinuity, but now this new scarcity rent, which starts at a lower level, is starting to increase at the rate of interest. It's better for the high cost reserves to wait, because given that they have such a small scarcity rent here for them, it's rising at more than the rate of interest, because they're starting with a lower baseline. So that's why they sort of align over time. It's not really what happens in the real world because the oil sands in Canada are really high cost and they're already producing. There's obviously also political constraints about when we produce and so forth, but that's what we basically use in this model. And then in this model, we basically have a choke price of $250 per barrel. This is also what Rystad uses, which is basically this idea that if it's $250, people don't have a demand for oil anymore, but below they have a demand. You might ask how expensive is $250? Well, it's actually what the current oil price is in the UK. So we know there's huge taxes on top of it, so it's not the raw price of the barrel, but it's hard to believe that there wouldn't be any demand anymore, $250, given that it's the current gasoline price in the UK. So basically what happens is this model is very, very simple. You basically want to see whether it's still profitable to basically produce oil. So what you have is you have the cost, the marginal cost of production at each oil well, which for existing wells is the sunk cost is no longer in it. For new wells, it's basically amortizing the investment cost of basically starting them. You have the tax and you have this backstop. And you only price out an oil well when the marginal cost is basically larger than the backstop minus the tax. So the only ones you basically price out are sort of those high cost wells. And so there's two effects that have basically the same, going in opposite direction of exact same magnitude. You can either have a carbon tax or you can have a decrease in the backstop. So alternative to what I show you in terms of a carbon tax could also be innovations in renewables that basically lower the price of the backstop. Okay, so we do some more sort of generalization, but I'm using more time than I thought. So you can generalize this with fixed cost and anything, but the intuition always goes through. So the important thing about a carbon tax is that, you know, if you have a $50 carbon tax, it impacts different fuels very differently. It basically would increase the coal much more than it would increase oil. So oil basically goes up 17 cents per barrel, while for coal, relative to the baseline price, the increase is much larger in relative terms. So a carbon tax definitely has a huge difference by making coal almost prohibitively expensive, but for oil it sort of leads to some increase. Now the thing about it is how much we have left in terms of carbon budget. There's different estimates out there, but basically we have about, you know, for this 2 degrees Celsius here, you know, there's a very small carbon budget left, and it's basically completely used up by just oil and gas. So even if you were to phase out all of the coal, we would still go through the limit. So this data has been used in this paper on optimal production allocation 2 is like an AR by Askanal, but we purchased the same data. Again, it's 15,000 discovered wells, 27,000 undiscovered wells. So you basically for each well, you sort of have an estimate from this Rystad consulting firm about how much it costs to produce from that well. So one thing that's nice to sort of check whether this model is completely off or not is when we simulate the model, we basically simulate it by backward induction, where we basically the last period you have to be at a choke price of $250, and then you simulate it downwards. That's what they do. In our isoelastic demand, we basically have two parameters, alpha and eta, and then we get like the price and the quantity consumed. And so, you know, we can pick this parameter, but then we get both price and quantity, but we have only one parameter to pick. So you can actually implicitly see whether the model makes any sense. And so what we basically get is if you have an interest rate of 3%, what Rystad uses, a backstop price of 250, this elasticity we took from Hamilton, and then we basically match the current Q to basically be 100 million barrels per day, which is the current oil consumption. Then we get endogenously from the model a price of 64, which is very much closely to what the oil prices are. If you actually use some other elasticities like 0.3 or 0.8 that are in there, you get oil prices which are very different from what the current oil price is. So the model sort of is at least internally consistent with this exploration. And so basically what you see here is, and this basically tells you the whole paper of the incidence of a global carbon tax. You see the discovered wells in blue, and you see the undiscovered one in this one, which is sort of more the high cost one, again, which you should wait for exploring later. You notice that it's very steep at the end. So basically an oil well drops out if its marginal production cost here plus the tax is larger than 250. So if you start putting up a carbon tax, you basically get rid of those oil wells. If you make the carbon tax bigger, you basically get rid of those oil wells, and you realize you have to go really high in the carbon tax to get to this chunk of the distribution where you basically price out the oil wells. This is sort of maybe with all the stuff I've shown you, the big takeaway is, you know, you sometimes hear, oh, solar's gotten so cheap, it's now at the same level of oil. But oil can get a lot cheaper, and Saudi Arabia still makes a profit. So they still can cut it by a factor of 10 and make a profit, so you need to get the solar prices even further down to really price out oil. Because you don't have to compare it to the current market price, you have to look at the price when it's still profitable for them to basically produce it. And so if you then simulate different carbon taxes, you see here, this is basically the baseline. path it's arrived at. So you see here the price for consumers on the left graph over time, and this is basically the change. This is the production quantity. You see how it's becoming less. We're phasing out oil. The price goes up until we hit the 250, the price path. Now you start putting in a carbon tax. You realize how the price initially some of it gets passed on. But then one thing that's actually curious is that because you extend the lifetime of this of oil being used, you see that the incidence is actually negative for later periods. And the reason is because the tax is imposed, so the scarcity rent is lower initially. It rises at the rate of interest, but since you start with a lower baseline, it rises slower. And so at some point, you basically get to this point where the price in the future is actually less under carbon tax than it would have been without a carbon tax. And as an extension of the time where you see you explore this, you basically extract it longer than you would have had without a carbon tax. And so this is then basically here shown. If you look at cumulative extraction, initially you basically produce less. That's why cumulative savings go up and up and up until this point where without a carbon tax you would have stopped, and then you extend the lifetime, and then you basically recover some of the savings. So even under like a pretty high, the red line was like $400 per ton, you would basically get only 15% decrease in global emissions, because most of it is basically absorbed by the producers. In a way, I mean, this is sort of an anecdote, but when I told Jeff, hey, I have an idea, we should write this paper, he told me, well, I've written this paper in 1980 with Joe Stiglitz. So it's just like, I'm really old, I'm way behind the curve. But basically what they wrote in the 1980s is a paper that said we should tax oil because there's no deadweight loss, because all of it is scarcity rents, and so we should tax it. It had nothing to do with climate. But the intuition is exactly the same as here. You can tax away scarcity rents because there's no deadweight loss, because the oil doesn't adjust. But by the exact same token, the carbon tax doesn't work because you don't pass it on to consumers necessarily, and therefore it doesn't work again. Now, talking about taxing oil, you might still want to do it from like a fiscal. Again, a carbon tax is strong incentives to get coal out. So I'm not lobbying against the carbon tax. Don't get me wrong. I want to be on record here. This paper is not to say carbon tax is a bad thing. I think one thing that I want to say, though, is that economists are sometimes overly optimistic how a price signal like a global carbon tax would just really give us large reductions in oil being used. I don't think that's necessarily the case, especially for the old social cost of carbon of $50 or $100 a ton, because if you really were to institute this globally, you just make countries like Saudi Arabia and the US, who's now the biggest oil producer in the world, poorer, because you tax away some of the scarcity rents. So what you will then do here, and the last one is you basically assume the same, very stylized facts here, back of the envelope. Same demand for every country of 0.06. We have the production well data from every single well, so that's detailed, but the demand is the same in every country. And then you basically look at different carbon taxes here, ranging from $0 to like $600, social cost of carbon, which goes up over there, as well as a carbon tax, which rises at 2% or 3.5% per year, so that really goes up over time. And what you see here is in the oil reserves used is for like here between 0 and 200, you almost use the same amount of oil over time. You might delay it a little bit, but it's not so much. Obviously, if you institute those carbon taxes, the producer surplus really starts to drop because producers now lose their scarcity rent. It explains why Saudi Arabia right now in Baku just lobbied really strongly against the wording that we want to get rid of fossil fuels. It just really takes away their scarcity rents. On the other hand, you get tax revenue, and so we sort of have a net impact on those. And this is what you basically see here. So Saudi Arabia really suffers because they basically have a huge reduction in the tax payments, and they have a huge reduction in consumer surplus. For producer surplus, we basically had to do an adjustment because the difference between 2A and 2B is basically whether you follow economic theory and say if you reduce Q, the high cost ones basically drop out. That would be column A. On the other hand, in column B, it's basically proportionally appropriate. A is proportionally appropriate to historic production. B is that only the high cost producers drop out. So it depends on which one you want to go with. But you see there's really strong overall minus 33, minus $14 trillion from like a $50 carbon tax. Why they might actually really lobby against this, because you're taxing away the scarcity rents.
Why do Brazil has such a large change in consumer surplus?
You mean here?
Yeah. Because it's the second largest, right? It's just behind Saudi Arabia. Saudi Arabia and Brazil.
Well,
It's not, it has nothing to do with oil, right? It's probably doing with agriculture and burning forest or something.
Okay, now I'm blanking here. This is a good question. Why is Saudi Arabia so? Did I screw something up here? So it's just the price adjusted. It shouldn't be population because it's also so. I think it has something to do. Okay, no. It's basically we have the demand elasticity. It depends on how much oil you use in the baseline, right? So if you have higher oil use in the baseline, it's the quantity times the price change in the area under it. So Brazil must use a lot of oil, like Saudi Arabia. I don't know why, but that's sort of what comes out of this. It's basically this is basically using data from the EIA on oil use in each country, and then basically looking at the price change and then looking at the consumer surplus loss due to that. So there must be huge amounts of oil use in Brazil. That's where this number comes from. Now it's a bit tricky because what do you think about oil production versus oil consumption? And there might be some funny thing in this table. Okay, so I'm running out of time, but so basically to just summarize again what I wanted to show you. So I think hoteling is still, I'm not giving up on hoteling yet. I think if you allow for discoveries, it still holds very much. I do think there is sort of empirical evidence that oil futures markets are very sensitive to climate legislation. That's sort of the second paper. And if you believe the sensitivity, if you had to institute a global carbon tax, it might actually lead to less carbon reductions than we think if a lot of it is just being eaten up by producers. But again, it also then explains in terms of lobbying why oil producing countries might be very strongly opposed to climate legislation, why it's so hard to get out of it, because unlike other environmental problems where we often have sort of technological solutions, here a lot of the incidence just falls on the producers. So happy to answer other questions you might have.
Time for a quick question.
So this is a Nearly article, which basically looks at, they just do a machine learning where certain words that are being mentioned in those newspapers. So it's New York Times. So it's not sentiment specific. So it could be both positive or negative. So that's sort of one of the qualification. But if you look at the raw data, this is basically what happens here over time. This is this polysalience. You see how climate change has become more prevalent. So it's just basically a standardized index about how many articles within a month have keywords that relate to climate, international climate treaty. So if you look at the policy index, you sort of see here what happens. This is the Rio de Janeiro summit, where like the UNFCCC was passed. This is the Copenhagen one. This is the Paris Agreement. So you get all these positive spikes about climate agreements that sort of correlate to major events in particular months. Now, the one qualification here, there's also Trump in there, which basically is the opposite sentiment, right? So this is not sentiment specific, but if you look through the data set, the majority of spikes are basically towards cooperation. And so then it's basically linking the oil return month to month to those events that happen that are this policy salience indexes on a monthly level. And you basically get, I can show you this, you get a significant result. Okay. Too many. Where did I have this? So this is the, yeah. So this is then basically just the standardized index, all futures on a monthly level, and then you have basically international climate agreement, the renewable policy, and overall environmental policy, and you do see this like negative return. So if there's more coverage of international climate agreement, the oil price has a 7% decrease, while per standard deviation. And for example, Paris was like 6 standard deviation above. So 6 times 7, it would be again sort of a 4% decrease, similar to the magnitude, while the renewable policy or environmental policy doesn't have any effect. Hope that's clear. Yeah, Harry.
So from a policy perspective, given the green paradox, is there any recommendation for an optimal policy? Say, for example, should we combine a tax on fuels with something like a heavy subsidies on renewables? Because what I think is going on, correct me if I'm wrong, is that I'm expecting an increase in taxes, right? And then I anticipate extraction right now, and the taxes remain flat, right, over time. Is there any optimal policy to try to mitigate that? Perhaps a variation of taxes, or perhaps combining taxes on fossil fuels and subsidies on something else?
So two-part answer. You can still do the economic efficient thing by basically saying, if you want to limit oil use, let's put a cap and trade on there. But if you believe the limit, the last one that we just showed you, what it would basically mean is it would extrapolate all the scarcity rents and give them to the government who now hold the permits. Because if it's basically equivalent to now, if you want the reduction that I wanted with a $400 tax, it basically means for that limit and the quantity, there's issues whether you can actually commit to this globally, right? But think for now, all countries could come together and commit to this. It will basically lead to a permit price that's just humongous, like $400 something according to this model. And then you basically ensure it's being efficiently used over time and there's no leakage. Now it's hard to do this, but obviously oil producers are completely against it and it might not be implementable. But that would be a first best that basically still gets the quantity restriction that you want. It just then implies you how high the price actually is because there's so much scarcity rent. Now the scarcity is with whoever the agency is who issues the permits. There's a second best, and I think this is where this is a paper maybe talking to myself. I used to teach my students every single year, carbon tax is the most efficient way, we should do it. That's why I started with this table. I think nowadays actually what the US has been doing, economists love to hate CAFE standards or other technological standards and industrial policy. But if I were to advise the government right now, I would say do a carbon tax because it also discourages coal, but at the same time put in some minimum standards so you basically prevent some of the leakage and also have a renewable policy to get those backstop price down. Because you have two margins to squeeze the oil wells out. One is sort of the oil price itself and the other one is the backstop. So I think that's sort of my revision of how I would advise. I wouldn't just say only carbon tax. I would now say do a carbon tax as well as some quantity regulation because this is sort of this unique situation of having an exhaustible resource.
Just to follow up, from the perspective of the intuition behind the model, is this something similar to Weitzman's results in the sense that once you introduce a price mechanism, then you change the marginal damages cost. And then a cap could become more attractive.
So I don't know which of Weitzman's articles you mean, but you mean the price versus but that has to do more about the uncertainty because we don't know what it is, right? It's sort of like the slope of the marginal cost and the marginal benefit curve.
Yes, but what I'm trying to say is that if you introduce a tax because you anticipate that and you extract more, then your marginal damage is going to increase right now. They're going to change. The elasticities are going to endogenously change. Does that make sense?
I think it still depends on the relative shape of the market because, okay, one step back here. I think I have a room which has this notion that climate change is bad and we should definitely do something about it. If you want to be sort of the Chicago school and be sort of the devil's advocate, if the social cost of carbon is $200 and that's correctly estimated, and at $400 we still use all the oil, we should just use all the oil because it basically means that the benefits of oil use is higher than the cost imposed on it. So the question here is how confident are you in the social cost of carbon numbers and so forth? Because it might really just be optimal to use all the oil if the costs are really lower than the use being generated by it, by the scarcity rents, what people are willing to pay for it. Now, in recent examples, and this is still working paper, but by like Bilal and Kanzik, they suddenly get like social cost of carbons that are $1,200, and then it wouldn't. But this goes back to your Weitzman article, because I think if the $200 social cost of carbon is correct that EPA uses right now, and if you believe my numbers, then it's just not optimal to do a stringent climate policy, and you don't have to worry about the tax effect of using more oil. You should do it because the benefits exceed the cost. All right.
I think that's it.
Thank you so much.
We have a coffee break right now. Thanks a lot to Wolfram. We have a coffee break, and the coffee break is right outside, and we get back in half an hour. Ryan Kelly presented the extraction with pressure here. And he started with a slide with ice cream cart, because he said, that's not the Hockling model I'm not going to talk about this ice cream sellers.
Oh, this is another one.
Yeah, and Manda um abraço pra ele, que eu gosto dele. Ele fez mestrado em Ribeirão.
Ele tá terminando doutorado em Kent e daí vai mudar pra Suíça.